Dengar angin kuat Okay, jap. Saya alihkan kipas.
Azizi, kita tengah set up lagi Ada bagi untuk dia. Okey. Jom kita try. Okay. Yang untuk yang semua orang belum bagi lagi Azizi, dalam tu belum ada yang pelajar masuk lagi kan? MC kita dah masuk.
Dah doktor dah, saya ada kat sini.
Aiza akan jadi MC
Ya doktor.
Okay. Okay. Okey, sebelum kita mula, saya nak tanya semua dah daftar SESCAMP?
Dah doktor.
Okey, kita section 2 dan section 6 saya dapati masih lagi ada masalah. Ada pelajar yang tidak mendaftar, jadi saya mohon sementara kita belum mula, awak daftar kerana untuk section lain kita dah ada kumpulan kecuali 2 section ini. Okay, so bila ada ahli yang tidak mendaftar, maka susahlah kita untuk buat kumpulan. Siapa yang buat aktiviti riadah, Aiza?
Untuk pagi ni Hafiz doktor.
Hafiz, okey Hadi. Hadi, mana si Acan? Belum dah masuk lagi?
Dia dah bangun dah. Dia on the way.
Oh, dia grup lain ke?
Dia dah ada ni. Dia on the way ni doktor.
Hari ni dia jaga YouTube
Boleh nanti saya beritahu dia.
Suruh dia jaga mesej-mesej di YouTube. Aduh, kesian mereka duk ucap selamat pagi dekat saya. Ya, saya mesej dalam YouTube ni. Baguslah you all semua ni. Sangat-sangat mantap lah. Okay. Tepat masa. Very good. Semua di YouTube pun sama. Sekarang YouTube kita dah 200 orang. Awak tahu tak total kita berapa orang sebenarnya?
Tak.
Kita ada 507 orang. Ramai, okey, ramai. So bila saya melihatkan awak ni semua begitu komit lah pada saya. Untuk hari kedua ni, pagi ni pun saya nampak di YouTube dan juga di dalam platform ni. Alhamdulillah. Okey, alhamdulillah semua. Okey, yang bekerja, ada tak yang sedang bekerja? Ada tak yang sedang bekerja?
Tak doktor.
Okey, so semua fokus Yang hari tu ada minta surat daripada saya, dah settle belum? Yang kerja di KBS. Apa nama dia ni? Siapa nama ni? Tak ada boleh buka apa-apa ke dekat YouTube tu? Mana? Aisyah, saya menganggur. Alah, relax lah. Sekarang kan bisnes online. Mana ada perkataan menganggur. Semua boleh buat sekarang ni. Jangan risau. Section 3 tolong semak ahli kumpulan awak. Ada yang tak sepatutnya berada di dalam section 3, berada di dalam section tersebut lah. Minta dia masuk ke section yang sebenar. Wow, kita dah ada lah sistem yang di Google Meet dengar tak?
Tengah total?
Dengar tak? Tapi tak jelas.
meneroka.
Pukul 8 kita akan mula
Okey doktor.
Hari ni baca doa siapa Aizah?
Aiman doktor, sama macam semalam.
Okey, di YouTube hari ni makan untuk tingkat Islam berapa ke apa ni? Aduh, tadi saya buka dua platform untuk cari dengar suara macam
Dengan
apa.
hikmah kita meneroka.
Okey, saya tengah mengulas di YouTube channel kita ni.
Boleh doktor, boleh.
Master panel makan bihun goreng dengan telur dadar secupit. Telur dadar secupit. Jangan, saya kopi pun belum makan. By the way, Kak Jumat start pukul berapa, Izzat? Masuk kita, 7.30 ni masuk. Wake up call. Kak Jumat start pukul 8. Okey, Izzat. Jatuh you di luar ambil sarapan. Lap. Kita ingat kenalan di asrama dia. Okey, yang di sini pun boleh lah bercakap. Play music sambil you sarapan. Andi, Nurul, Amirul. Dan nama dia. Ni nak starter program. Nanti Aizah macam mana you nak control ni Hadi? Hadi ke Aizah? Yang
Kita orang dah ada reserve 2 tempat untuk panel sebutan.
dan nanti dah sekarang belum?
Saya nampak doktor je.
Hikmah kita meneroka.
Oh ya ke? Amboi. Dah kejutkan pensyarah seksyen nampak. Okay, dalam grup saya ni mereka sudah ada dah ni. Aizah, saya akan share slide kepada awak. Katalah drama hari ni dia tak dapat buka kerana kita risau drama luar sebab dia pakai akaun lain. Saya minta awak standby lah. Okay. Ke Aizah perlu kata yang lain?
Boleh orang angkat doktor sebab doktor saya tak boleh share.
Saya pas dalam grup betul silat Silat tu apa tadi tu?
Pelajar UTHM ke doktor?
Ya. Kita kena tengok. Haji ke yang akan keluar nanti?
Ada saya dengan seorang lagi.
Tim Yijing, you boleh bantu tak?
Apa doktor?
Boleh bantu tak? Boleh saya share slide ni, nanti awak untuk slide ni ceramah. Sekiranya ceramah menghadapi masalah. Boleh?
Boleh doktor.
You dalam session 1 kan?
Session 7.
Saya share dalam
Yes.
saya share dalam grup aku
Okay.
Dr. Fendi tak berjaya masuk pada dapur. Boleh tak? Tak cukup kot Hadi, 2 orang. Standby. Tak apa. Awak stay.
Boleh. Ada dalam 3. Doktor nak laporan barisan.
Sekejap saya tengok kan perjalanan ni siapa yang nak masuk tapi saya minta dia masuk dalam listrik lah. Ada juga yang masuk dalam listrik. Wow, berapa kali nak ulang lagu ni? Amboi. Apa nama? Khairul Aiman. Hai. Tak nak dengar ke lagu tadi ni? Dia rindu sikit Tak nak dengar pula. Okey, kita stopkan lagu ni. Azizi boleh stopkan lagu ni? Tak lagu M. Nasir. Amboi, ingat semua orang suka M. Nasir. Boleh Azizi stopkan lagu tu? Okay, lagu dah berhenti. Dah Azizi? Okey, kita penceramah Okey, kita tinggal lagi beberapa minit untuk ke jam 8 yang mana program kita akan bermula. Di dalam YouTube masih lagi kita kurang ahli baru 288. Saya harap yang lain tolong masuk Ya Aiza. Aiza, saya dah maklumkan kan kita punya penceramah akan masuk jam 8. Biodata penceramah kedua siapa? Boleh Aiza. Okey Aiza, tepat pukul 8. Aiza boleh mula. Okey, Aiza boleh mula dengan kita punya masa. Apa kata sekarang kita dah mula buat riadah kot, Aiza?
Buat apa doktor?
Kalau nak mula dengan riadah pun boleh juga tapi
Boleh, instructor pun dah ada dah. Hafiz dah masuk.
okey boleh. Nanti bila penceramah masuk, awak akan mula dengan bacaan doa kot.
Okey.
Okey, yang ni macam ni lah sebelum apa-apa pun. Okey semua dengar saya kan dengan jelas? Di YouTube pun dengar saya?
Alhamdulillah jelas.
Okey, good. Baik, apa-apa pun yang kita buat, okey, untuk pagi kita perlu ada rasa semangat dan rasa ceria. Okey, untuk itu kita mulakan dengan bacaan yang baik. Okey, dengan niat yang baik. Kita mulakan dengan surah Al-Fatihah bagi yang Muslim. Bagi yang bukan Muslim, saya pasti setiap agama ada cara-cara yang terbaik untuk memulakan hari baru, hari di waktu pagi. Okey, so ikut agama masing-masing, baca, lafaz niat untuk program kita hari ini. Okey, Al-Fatihah. Okey. Sekarang saya serahkan kepada tim yang telah dilantik untuk buat aktiviti riadah. Okey. Selepas ni kita akan ada bacaan doa apabila penceramah masuk. Okey, Aiza, clear?
Okey doktor, clear.
Okey, so bagilah pada riadah. Okey, kita mulakan dengan riadah pagi. Silakan.
Okey, saya nak jemput instruktur kita pada pagi ini untuk riadah, untuk kita fun dulu sebelum kita start camp. And boleh tak saya nak minta semua turn on camera? Oh, termasuk saya tadi. Okay, turn on your camera. Okay. Semua muka energetik. Okay, bagus. Okay, muka semangat, okay? Untuk hari, kita baru hari kedua, so kita kena energetik lagi lah. Okay, so saya jemput instruktur kita, Hafiz, untuk take over untuk riadah kita pada pagi ini.
Okay, sorry. Assalamualaikum warahmatullahi wabarakatuh semua. Sekejap saya tengah setting kamera.
Okay Hafiz, boleh saja. Okay, semua sihat hari ni?
Semua okey ke hari ni?
Sihat, ceria.
Sehat.
Yes. Hafiz,
Ya saya.
Nur Aizan, kenapa tak bersuara ni? Ya
Saya
Allah.
bersuara. Okey, sebelum tu saya nak minta saya punya partner for stretching ni, Mai Sarah. Ada ke? Mai Sarah?
Ya saya.
Sebab kamera saya ni tak dapat lagi nak setting. Jadi Mai Sarah boleh tolong handle the some light stretching jap? Macam
Stretching.
semalam, macam yang petang semalam tu je. Sebelum kita start.
Okay. So macam kena warm up dulu kan? Boleh. InsyaAllah. So, insyaAllah saya membantulah kepada Hafiz pagi ni. Semua dengar ke saya punya suara? Clear ke?
Clear.
Clear.
Okay, insyaAllah. So, okay, semua orang just get ready lah with your hand and then so on. Okay, so just slide je macam like ringan-ringan je untuk part kepala dulu kita akan buat. Okay, kita counting lah sama. Okay, ke atas. In 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Alright, and then down. 1, 2, 3, 4, 5, 6, 7, 8. To the right. 1, 2, 3, 4, 5, 6, 7, 8. To the left. 1, 2, 3, 4, 5, 6, 7, 8. Okay, next we move to your hands. Okay, so tangan ke depan. Okay, sekarang betul-betul tau, bagi kita semangat sikit. Ya, okay. 1,
Buat
2,
kita rekod ni, ambil kakak, ambil.
5, 6, 7, 8. Okay, and then flip. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Then ke hadapan. 1, 2, 3, 4, 5, 6, 7, 8. Okay, then tangan kiri pula. Okay. Ke hadapan. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 pula dah. 8 je. Lebih masa pula. Kita baca komen kat YouTube katanya terlebih laju. So saya slowkan sikit lah ya.
Lebih laju. Okey.
Okay, so kita just slow. Alright, sorry. Okay.
Kawan-kawan okey.
1, 2, 3, 4, 5, 6, 7, 8. Okay, ke depan. 1, 2, 3, 4, 5, 6, 7, 8. Okay, semua sakit bahu tak? Macam
Sangat lagi.
Ya, doktor.
Muhammad Zuhaimi siap sangat lagi. Sempat muak lagi. Kalau
Okay.
siapa nak muak sekarang.
Lepas jangan muak lepas ni. Kena semua kena fokus. Okay, next kita go kepada bahu langkah Bahu macam part penting kan. So kita ke depan lah. Okay, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay, next kita counter clockwise 1, 2, 3, 4, 5, 6, 7, 8. Okay. Next, siapa lagi? Semua orang nak buat apa? Okay, Hafiz dah boleh over. Hafiz okay ke di situ? Hafiz? Masih ada masalah teknik?
Sakit bahu. Yang dekat ni
Sakit
semangat.
bahu. Penat ke semalam? Okay ke perbincangan dengan doktor malam tadi? Semua orang macam kena keep on semangat lah. Okay, next kena tangan kot macam ni Okay ke? Buat macam ni. Okay.
Sedap.
Okay. Get ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8. Next kita ke belakang macam ni. Okay, semua orang. 1, 2, 3, 4, 5, 6, 7, 8. Okay, semua sampai tak tangan kat belakang? Sampai tengah pendek. Okay, ni dengan menguji sikit. Ya, okay, go. 1, 2, 3, 4, 5, 6, 7, 8. Ya, okay. Move to your left hand. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Next. Tadi belakang semula. Okay. Ni agak crucial sikit. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, rasa tak kita dah renggangkan otak kita. Okay, last. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Wah, dalam komen. Jangan tak sampai macam mana? Sampai-sampai kan lah. Tak sampai
Buatlah
pun
bagi
kita baju ke apa. Kita
Kan?
paksa lah kan. Okay.
Saya pun tak sampai
Rasa-
juga.
Rasa bertenaga tak semua orang? Okay, hopefully semua orang dah makan lah kan, dan ada sikit lah snack dekat tepi meja ke. So kita boleh fokus lah kan. Tapi jangan terlebih makan. So lagi ngantuk. Paling bahagia lah benda tu. Okay. Rasa sadar. Mantap betul. Sampai
Okey, cepatlah tepukan dekat Maisara.
Okay.
Thank you Maisara. Thank you so much. Hebat
Alright.
Maisara.
Ya betul?
Hebat Maisara. Okay, you in charge semua video bagus.
Okay, Alhamdulillah.
Aku nak
Okay,
record.
cikgu lah kan. Saya serahkan kepada MC ke, Aiza?
Hafiz tadi ada lagi tak?
Hafiz ada apa-apa ke? Saya macam dah okey. Kalau nak gerakkan pinggang sini pun okey je. Ikutlah yang duduk di atas kerusi. Jangan duduk atas kaki
kan.
juga lah. Takut je terus terlena je.
Ada di atas katil ni. Henry atas katil
Ni
ni.
nak tak open kamera tu satu ya. Kat mana semua orang? Risau juga ni, kat mana? Harapnya semua di atas kerusi lah ya. Okay. Dah kot, insyaAllah kalau Hafiz macam tak ada menunjukkan sayang apa-apa, so saya rasa bolehlah diserahkan kepada MC.
Okey, semua macam mana? Dah bertenaga ke di Google Meet, di YouTube semua okey ke?
Okey.
Respon sikit. Respon
Okey,
sikit, saya tak dengar
okey.
suara lah.
Okey.
Okey.
Okey. Okey, 3 orang je okey. Yang lain tak okey. Yang off camera tak okey.
Okey.
Okay.
Okey.
Respon ke? Respon.
Okey.
Okey, macam ni lah yang kita nak.
Rasa sadar dah.
Rasa sadar dah? Oh, yalah PKP ni kan. Okey, siapa yang dah dapat vaksin? Siapa dah
Baru
dapat
first
vaksin?
dose.
Oh, mesti ramai lagi yang tak dapat vaksin kan? Saya pun tak dapat lagi. Okey, kita nak buat apa lagi?
Marilah kita borak-borak sementara. Okey. Okay, ada apa-apa yang nak share tak? Kita tengok dekat dalam YouTube. Menjerit. Okey. Okey, dia ni. Okey.
Okey, saya nak minta maaf dulu awal-awal. Agak bising, ada bunyi kereta, lori, apa semua lalu sebab rumah saya tepi jalan. So, saya minta maaf lah kalau tiba-tiba saya senyap tu, saya tunggu kereta lalu dulu. Okey? Okey. Borak pasal Azizul Hasni. Sejujurnya saya tak tengok semalam, saya tahu-tahu je dah menang. Tapi okey lah kan sebab Datuk Azizul, semangat beliau tu memang kita boleh contohi. So saya rasa student-student semua okey kot. Lagi satu, saya nak mohon untuk semua Muslim untuk sedekahkan Al-Fatihah kepada salah seorang artis yang kita kenal, Siti Sarah, yang telah menghembuskan nafas terakhir pada 5 pagi tadi. Jadi kita ambil sedikit masalah untuk membacakan Al-Fatihah untuk Siti Sarah, arwah Siti Sarah.
Sebenarnya bukan pada arwah Siti Sarah saja artis kita ramai saya rasa ramai di luar sana yang kita kehilangan sahabat, keluarga, okey, terlalu ramai di luar sana dan kita juga sedang menghadapi dugaan ini yang mana kita menjalankan platform camp geomatik yang tak pernah tak pernah pun kita terfikir kita punya camp yang sepatutnya kita pegang alat, Okay, kita berpanas, kita berhujan untuk siapkan sewekian ni kita terpaksa buat begini dan saya harap semua daripada kalangan kita yang ada dekat sini positif dan positif. Jangan hanya menunding jari menyalahkan itu ini. Cuba fikir dengan tenang. Okey, apa yang orang dah buat dekat kita, bagaimana orang merealisasikan perkara ini bukan sesuatu yang mudah. Okey, yang duduk, yang buat sahaja yang rasa. Okey, berbalik kita kepada kengkangan ketika COVID ini, sekali lagi saya minta semua yang beragama Islam dan yang beragama Buddha, Hindu, Kristian, apa saja agama, semua agama ketika ini sedang mendoakan semoga bencana yang kita hadapi ini cepat berlalu. Okey, jadi saya harap awak semua kena ada perasaan yang sangat-sangat sensitif dengan COVID ini dan minta kepada Yang Maha Esa semoga perkara ini berlalu. Okey, mari sama-sama kita membaca bagi yang Islam sekali lagi Al-Fatihah dan bagi yang agama lain ikut amalan agama masing-masing. Fatihah. Semoga nyah COVID di muka bumi ini nyah pergi jauh.
Amin. Tak sabar nak balik kampus.
Kan?
Walaupun dah nak habis.
Nak belajar saya face to face.
Sempat merasa satu sem je doktor dekat kampus, sedih rasa.
Memang betul lah tu.
Tapi
silakan Aiza.
Tapi apa yang saya nak cakap tadi? Okay, tapi saya rasa macam bersyukur jugalah. And then kawan-kawan saya, sebab ramai ni dalam batch saya kan, so ramai lah kawan-kawan saya dalam ni juga, dalam camp ni. Diorang pun cakap dengan saya yang bersyukur jugalah at least satu sem merasa dekat kampus. So dah ada kawan-kawan apa semua. Bagi yang kat bawah-bawah batch yang tak balik kampus langsung tu, kesian lah.
Sebab itulah kan, yang lain pun boleh menyampuk sama-sama sambil saya tengok di YouTube channel ni. Sebab itulah kita jangan cepat melenting. Jangan cepat terus post di FB, terus post di Insta. Apalah ini, apa itu. Anda tak tahu setiap orang, setiap daripada kita ada dugaan yang dilalui dan bagaimana dia untuk membaiki perkara itu. Contohnya dalam pembelajaran anda komen memang senang kita lontar. Okay. Tapi bayangkan bagaimana Aiza sekarang nak kontrol platform ni. Apa yang dia rasa kalau anda semua tak bagi respon. Dia rasa macam syok sendiri. Macam sekarang saya boleh rasa macam syok sendiri. Tapi nasib baiklah Azim buka kamera. Nampaklah Azim sedih, Zuhelmi, okay, Maisara, Izzati. Jadi saya boleh nampak awak semua bagi respon baik di dalam platform YouTube yang komen. Inilah sebenarnya orang yang kendalikan program, dia nak yang macam ni. Supaya dia pun tak rasa macam apalah aku ni bagi apa faham ke tidak. Jadi saya harap nanti setelah kita jemput penceramah masuk, penceramah yang kita panggil kali ni bukan calang-calang orang, yang beliau memang buat praktik amalan geometrik dalam bidang dia. Bidang awak itu civil engineering. Okay, so saya dah bersedia untuk menjemput penceramah ni masuk. Yang lain ada apa-apa nak bercakap tak sementara penceramah belum masuk? Saya share slide di kepada Teng
Okey, doktor.
Okay, you try buka dia punya yang pertama. Tapi once Tengok dulu. Okay, saya dah send.
Doktor nak tanya.
Ya, silakan.
Berkenaan dengan nota-nota yang slide-slide taklimat semalam dengan hari ni, kita boleh dapat kat mana
Okey, yang taklimat semalam, untuk taklimat 1 saya dah bagi. Ketua seksyen semua dah edarkan, betul?
Dah.
Untuk taklimat 1 sudah. Okey, taklimat 2 dan taklimat 3 itu adalah menjurus kepada projek. Kalau awak nak just recall, untuk taklimat 1 tu boleh pergi kepada YouTube lah. Okey. Yang akan keluar untuk kuis nanti ni adalah taklimat yang betul-betul taklimat 1, taklimat hari ni taklimat 5 lah kan? 4. Taklimat 4 dan taklimat 5. Okey. Namun begitu, setelah Cik Lily kita beri pada saya slide tersebut, kesemua slide saya akan letak dalam platform atau masing-masing, ataupun saya dan juga saya akan bagi kepada pensyarah masing-masing serta ketua masing-masing. Banyak medium awak boleh ambil. Okey Aiman.
Okey doktor. Baik, terima kasih.
Sama. Ada lagi tak nak tanya? Okey, saya rasa saya nak jemput penceramah. Ting dah boleh tengok dah? Slide.
Sudah boleh.
Okey, so penceramah akan masuk. Serious. Ya betul. Okay, kalau kita tengok dalam YouTube channel kita, dia tanya quiz kat mana? Quiz kat atas So sebentar lagi semua pensyarah seksyen akan tarik nama-nama anda masuk dalam enroll nama seksyen masing-masing. So, jangan risau. Quiz pukul 2 kan? Nama je quiz. Actually kita nak lihat sama ada semua pelajar beri perhatian atau tidak dan faham atau tidak ceramah yang diberikan. Ini je adalah salah satu caranya. Bukan setakat awak je yang ambil ujian tu, saya pun ambil. Okay, kita nak tengok betul ke yang kita faham dengan apa yang penceramah cakap. Dan di samping itu dia menguji kefahaman kita terhadap bidang geometrik. Itu je. Jadi kalau kata awak recall dengan bahan bacaan geometrik pun okey. Yang awak dah belajar dalam subjek geometrik. Kan? Azwan Aiza, Dr. Azwan tau.
Dr. Azwan Izani.
Boleh lihat-lihat kalau dah Dr. Izani dah masuk. Ni Surveyor Khairul Nizam ada beritahu melalui classroom berikut di dalam artikel untuk semua section. Dah ada okay, terima kasih Cik Khairul Nizam. Dr. Izani dah masuk?
Macam belum.
Okay, tak apa. Saya dah call. Kita mungkinkan.
Okay, untuk yang lain. Untuk yang lain, please turn on your camera and turn off your mic unless you have to use your mic.
Aizah, dalam YouTube kita dah ada pula yang dislike. Amboi, baru 20 like.
Itulah. Mohon bersabar ya semua. Mohon sabar.
Sedihnya. Tak sokong ke kita?
Assalamualaikum semua.
Salam. Siapa ni? Siapa yang cakap tu?
Okay, ni Hafiz tadi. Hafiz baru dapat on cam and everything. Oh, minta maaf kepada yang menunggu dekat Google Meet and dekat YouTube sampai ada komen buang saya. Siapa yang komen tu? Okay, so first of all, minta maaf tadi maybe ada yang terlepas. So for refreshing balik, saya minta jasa baik semua orang untuk get ready balik depan laptop sambil-sambil menunggu doktor menceramah masuk and support each other dekat semua platform, and you guys can bawa notes or everything dekat depan korang dulu. Actually sebelum start lah, tapi tak tahu lah doktor penceramah sudah masuk ke belum. Saya just nak berinteraction dengan korang lah sebelum lah. Tapi kalau doktor penceramah dah masuk, MC lain boleh alertkan saya. Okay, siapa dekat Google Meet lah, senang. Siapa dekat Google Meet yang pernah main sukan sampai wakil Malaysia? Boleh reply dekat komen. Ataupun dekat YouTube pun kalau nak reply pun boleh. Tidak pernah. Okey, dua orang jawab tak pernah. Okey, kita turunkanlah sikit. Siapa pernah main sukan sampai wakil negeri? Okey, sepatutnya orang macam ni dia kena banggalah. Dia wakil kan? Dia wakil. Dia terbaik antara yang terbaik. Okey, seorang Kasih Tria. So untuk menjadikan majlis hari ini meriah, boleh tak saya minta Kasih Tria untuk bercakap serba sedikit, tak perlu open camera or apa pun, serba sedikit tentang pengalaman yang beliau jadi atau mewakili negeri tersebut. Boleh ke? Ada respon?
Boleh, insyaAllah boleh.
Okey, Alhamdulillah. Okey, yang kat YouTube and Google Meet boleh dengar apa dia punya sharing. Okey, Assalamualaikum Kak Sitria. Okey ke?
Okey, waalaikumsalam.
Okey, Kak Sitria pernah mewakili sukan apa?
Tapi ni zaman saya sekolah menengah.
Oh, tak kisah.
Tak
Maksudnya
kisah kan?
tak kisah zaman sekolah menengah, zaman tadika ke, pernah mewakili. Okey, Kak Sitria boleh share apa yang Kak Sitria mewakili ya?
Okey, saya sekolah menengah saya belajar dekat sekolah menengah Sains Pasir Putih. Which is semua perempuan. So kita orang saya participant untuk HKSBP basketball.
Oh, tahun 2000 apa?
I tak ingat. 2015 kot? Tahun 2015.
2015.
Ha, ha.
Jadinya Kak Sitria ni umur 23 atau 24 lah.
Yes. Dah
Okey
tua
okey.
dah.
Kiranya okey macam ni Kak Sitria. Saya pun pernah mewakili dalam HKSBP, tapi saya kira junior awak lah kot. Saya boleh
Yes.
panggil awak kakak lah. Tahun 2016 saya pernah. So terima kasih kepada Kak Sitria sebab sanggup telah share apa yang dia wakil. Jadi kita boleh tanya, siapa-siapa pun boleh tanya Kak Sitria macam mana dia punya orang panggil apa lah, persiapan sebelum nak berlawan dengan sekolah-sekolah lain.
Ya.
Ataupun Kak Sitria sendiri boleh cerita dia punya persiapan macam mana, jogging dia berapa
Okay.
ah.
Untuk saya, my coach dia ajar kita orang macam firstly fitness lah. Sebabnya basketball of course lah kita lawan China kan yang lebih pakar, lebih orang kata lebih kuat daripada kita. So
Coach Kak Sitria ni orang Cina lah.
Tak, tapi dia belajar dekat luar negara lah, which is Paris tu lah. Okay, so dalam seminggu tu kita orang akan ambil 3 hari buat 3 kali 7 round padang. Which is
dalam seminggu 7 round padang.
7 round padang tu 3 kali lah. Ikutlah Ahad, Selasa, Khamis ke kan. And then tiap-tiap hari buat sejam fitness lah. Sejam tu fitness, angkat masa apa semua, plank, push up, two side, semualah. Everything lah. Kalau tak masuk, popping 20 kali, round court, itulah. Pengalaman saya bersyukur masuk basket ni sebabnya saya boleh pergi luar negara dengan basketball. Kita buat family friendly match.
Saya pun tak pernah.
Okey,
hebat.
Hadnya yang Singapore.
Okey.
Since sekarang dengan COVID-19 saya macam terfikir kat lah sebabnya before this saya rasa macam sedih juga. Saya masuk basket agak terganggu pelajaran saya. Tapi bila fikir-fikir balik saya rasa apa orang kata
berbaloi
lah kiranya sebabnya macam ada pengalaman baru yang kita dapat. Pergi negara orang pun macam sekarang dah tak boleh kan. Buat macam kata tak boleh buat masa sekarang ni lah.
Memang hebat. Okey, semua actually memang hebat sharing daripada Kak Sitria ni. Dia punya penceritaan pun sangat menarik, daripada training, daripada dia pergi luar negara buat friendly. So actually korang tertanya-tanya tak? Saya tak tanya pun dia menang ke tak. Korang tertanya-tanya tak? No, wait. Pasal menang ke tak tu actually is a different story. Okay, saya tanya korang semua. Kalau korang masuk satu competition, korang nak menang tak? Saya tanya kita punya Dr. Nazirah lah. Kalau Dr. Nazirah main lumba lari kan, Doktor nak menang tak?
Nak.
Confirm nak menang. So itu adalah spirit pemenang. So sebelum nak memulakan apa-apa, kita memang nak kita jadi terbaik. So at least kita dah buat latihan, kita dah buat sukan riadah, latihan intensif, everything untuk menjadi pemenang. At least usaha tu kita dah ada, then barulah kita beralih kepada story yang menang atau tak. So adakah kita punya penceramah sudah dah sampai?
Ya, penceramah dah masuk.
Okey, alhamdulillah. Terima kasih sebab semua masih mendengar dan stay macam ramai menarik pula duduk depan laptop. So jadi saya akan kembalikan kepada MC. Terima kasih semua sebab hadir pada hari ini. Assalamualaikum.
Kita bagi tepukan dekat Hafiz. Terima kasih. Okay, Aiza, the floor is yours.
Okay, baik. Terima kasih. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. My name is Aiza and I will be your MC for today. First of all, let's say thanks to God who has been giving us guidance, happiness, and healthy so that we can attend and participate in this geometric practice camp day 2 without any obstacles. So before we start our camp for today, I would like to call upon Muhammad Aiman bin Muhammad Nasir to lead the prayer. As for non-Muslims, you can pray according to your own religion. So Aiman, the mic is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Al-Fatihah. Auzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin arrahmanir rahim maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajmain. Ya Karim ya Wadud, sesungguhnya kami berhimpun pada hari ini bagi menyatakan kesyukuran di atas kurniaan-Mu yang tidak ternilai Allah. Jadikanlah kami hamba-hamba-Mu yang sentiasa bersyukur sama ada nikmatnya sedikit, lebih-lebih lagi nikmat yang melimpah ruah kepada kami ya Allah. Ya Allah, Ya Rahman, Ya Rahim. Engkau berkati dan rahmatilah perjalanan majlis program amalan kejuruteraan geometri ijadah saudara muda ini ya Allah pada sesi 2021 ini. Sesungguhnya Engkau Maha mengetahui bahawa kami di sini ingin menimba ilmu-Mu yang sangat luas bagi mengembangkan ilmu pengetahuan kami sebagai hamba-Mu yang Engkau redai ya Allah. Justru berkati dan rahmatilah perhimpunan kami ini. Kurniakanlah kepada kami ilmu-Mu, sinarilah hati-hati kami dengan cahaya dan hidayah-Mu. Semoga dengannya kami mudah menerima dan menghayati serta mengamalkannya ya Allah. Ya Zal Jalali wa Ikram. Kurniakanlah jua kepada kami kesihatan anggota, kecergasan minda, ketenangan jiwa, kekuatan semangat. Semoga dengannya kami mampu mendepani cabaran, berdaya saing dan mampu mengangkat martabat kami, warga, masyarakat serta negara ya Allah. Rabbana taqabbal minna innaka antas samiun alim. Allahumma zidni ilman warzuqna fahman. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar wa qina azabul wa qina azamasyar. Wa sallallahu ala sayyidina Muhammadin wa ala alihi wa sahbihi wa sallim. Walhamdulillahirabbil alamin. Taqabbalallahu minkum.
Amin, amin, amin ya rabbal alamin. Thank you Aiman for the doa. Okay, so we already went through 1, 2, and 3 briefings yesterday. So today we have left 2 briefings more. So the fourth briefing for this morning is the usage of survey data in engineering work that will be given by Dr. Azwan Izani bin Azmi. So before we start, I would like to introduce a bit about our speaker for this morning because tak kenal maka tak cinta, right? So Dr. Azwan Izani Azmi has completed his PhD in civil engineering at the University of Birmingham in June 2021. He was graduated from UKM with Bachelor in Engineering before he completed his Master of Science in Road Management and Engineering from the University of Birmingham in 2012. His first posting at JKR was as civil engineer at Road Maintenance Unit, Road Branch in 2005. Since then, he has developed his interest in road asset management. So, he has more than 10 years of experience in JKR, especially in planning and monitoring federal road maintenance in Malaysia. He was also part of the committee who reviewed the Federal Road Maintenance Agreement for Peninsular Malaysia. His last placement in JKR is as a senior civil engineer at the JKR Director General Office from July 2014 until October 2015, before he continued to pursue the PhD level. So currently he is responsible for the maintenance of bridges at Cawangan Senggara Facility, Jalan. Well, without wasting our time, let's start our first briefing for this morning. It's an honor to have our first guest to start. Datuk, Doctor, the floor is yours. Dr. Azwan, are you there?
Dr. Azwan.
Oh, internet connection. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Thank you very much, Mrs. Chairman, Cik Nur Aiza. First of all, I would like to thank UTHM and also the organizer for inviting me, especially Dr. Nazira. He was contacting me a few times to get me, and in the end, today is the day for me to deliver this lecture to all of you. It's a very good opportunity for me to share some of probably our knowledge in public work department or Jabatan Kerja Raya in doing road construction and other infrastructure development in Malaysia. And what we're going to share today is basically what we do in terms of which is related to engineering survey. Can you hear my voice clearly or not? Before I start.
Yes, Doctor, yes.
All right, good. Okay, I would like to share my slides. Okay, I have shared the copy of this slide with Dr. Nazira. Can you see my slides now?
Yes, Doctor.
Presenting now? Yes. Right. Yes, good. Okay, this is the title that has been given by Dr. Nazira to me. How does data in land surveying work? Practical engineering. Okay, what I'm going to share basically is the application of land surveying data or basically the engineering survey works data that normally we collect, and how we use it in infrastructure project. All right. The content of my jury probably so I have to a little bit explain part of it so that we will see what are the connections between the and also the application, the real application of it. So and then after that, we're going to see the application of engineering survey. We will discuss with the conclusion. Before I continue with the the first section. Can I know what time I'm supposed to finish this lecture?
It may be 9:30.
9:30, okay. So introduction, okay. What is surveying? Surveying is basically an art, a science and art of measuring, recording, and drawing to scale the location, the size, and the shape of natural and man-made features on the surface of the earth. As you can see here, it consists of science and also art. Means that when we talk about science, it is something that we produce based on certain specification, certain standards that whoever do, if they follow the same procedure, we will get
Dr. Azwan.
Okay, can you hear me clearly now?
Okay, Doctor, super clear. But can you raise up the volume a bit? Dr. Azwan is lah. Okay, guys. So this is the technical issue. So I hope you guys hang on. Okay.
Okay, can you hear me clearly now?
Yes.
Yes, Doctor.
Is the slide has been shown? Can you see the slide?
No, Doctor. No slide.
All right. Sorry. I hope you get part of the what I've been explaining just now. Okay. Basically, surveying is science and art. Means that if you're talking about science, if you do some data collection based on your survey procedures, if you ask somebody else to repeat the same procedure, you will get the same data, some sort of a replication of the data. And it also an art. It means that there are possibly a couple of ways to carry out the surveying work. That's why we call it art. Okay. All right. Aims of field survey is basically firstly to measure the horizontal distance between points. Means that you want to gather the distance between the location you are sitting on and also the location that you are going to get from the other objects. Secondly, to measure the vertical elevation between points. This is in terms of we call it in terms of Z direction. Just now in terms of X and Y direction. Thirdly, to find out the relative direction of lines by measuring horizontal angles. What are the angles between those two objects. And fourthly, to find out absolute direction by measuring horizontal angles with reference to fixed direction. So if you have two different objects, you're going to measure the angles and also the direction, and also including the distance of the objects. So these parameters are utilized to find out the relative or absolute coordinates of a point or location. The reason to perform survey, firstly to collect data, which can then be drawn to scale on a plan or map. Secondly, to precisely design the construction project based on the original ground condition. And thirdly, to lay the dimensions shown on a design plan in order to precisely define the field location for the proposed construction project. As you can see here, there are three things that we do with survey. First, we collect the data, and then we use that data for design work. And then after that, we use again the same data, including the design that we have performed, to precisely lay the design on the site, on the construction project. Okay. First of all, we need to understand what is the difference between map and plan. Okay, map, whenever you survey a large area, you will try to include everything in that map in a small area, and you have a very big scale, 1 into, for example, 10,000 or 1 into 100,000, that we call map. So in this situation, the scale of the objects that we survey basically is not really important. For example, map of Putrajaya or map of a certain place or locations. Okay, plan. Whenever you do some survey in a small area and the scale to which is result plotted is large, means in terms of the accuracy of the plotted area is considered big. So this what we call plan. Most of the time, we refer this to a plan of a project or construction or something like that. The scale will be about 1 to 100 or 1 to 200 or 1 to 500. Okay, I'm going to talk about the classification of surveys. Okay, basically there are 4 ways how we normally classify surveys. Firstly, based on the nature of the field. Secondly, based on the method itself. Thirdly, based on the instrument used to carry out the survey. And fourthly, based on the objective of surveying. Okay, we are going to look at the first way of classifying the survey work. Firstly, based on the nature or place of survey. Type of the survey that normally we carry out are firstly land survey. It includes city survey. For example, we want to survey the whole city. Engineering surveys, then topographic survey, cadastral survey. All these can be described as land survey. And then secondly is hydrographic survey. Hydrographic survey is whenever there are water bodies, for example, river, lake, or even sea, you need to carry out the hydrographic survey. This picture basically is about a hydrographic survey has been carried out by a ship on the sea, to carry out to collect the data of the seabed. Okay, and then underground survey. Fourthly, thirdly is underground survey. What we do basically to do the utility mapping like this. In this picture, we will try um, to do some sort of scanning of the underground utilities to identify what kind of utilities available underground. For example, maybe the um, water pipe, or maybe a telecom lines, or even electrical line. And fourthly, the aerial survey. Now, aerial survey is quite cheap compared to the last 10 to 15 years, because before this, we have to use the aeroplane or helicopter to carry out aerial survey. But now, with the current technology of drone, we have unmanned aerial vehicle, which is very cheap to carry out aerial survey. Okay, secondly, based on the method, okay, uh, first method is triangulation survey, like this picture. It is based on angle, and then based on the angle of two objects, we can identify what are the location of that object easily by understanding how the angle and also distance of that object to the location that we are sitting on. Secondly is transverse survey, like this, transverse survey, where we transfer the survey location from A to B and C and so on, so that it become a closed loop. This is where we call it transverse survey, close transverse survey. And this is the kind of transverse survey that we normally carry out to do the engineering survey for construction, for road construction. It's normally open, but this is subject to a very big error. And then what we normally do is in the end to close the transverse by coming back to the origin of the survey. Okay, thirdly, it's based on the instrument they use. We have chain survey like this. Normally, they use about 100 link of chain. The total length is about 660 yards, 66 yards normally. We not use much currently, because there are some other instruments that is more accurate nowadays. And then this is compass survey. This is plane table survey. This is also not very accurate. All these are suitable only for a small area. And this is tachometric survey. This one is tachometric survey, and this guy is doing the survey using theodolite or total station. I hope that your previous lecture has explained all this type of survey deeply. But I still have to repeat this so that we can see what is the connection between the survey work and also the application of the survey work itself. Okay, fourthly, based on the purpose or objects of survey, we have engineering survey that we're going to that I'm going to explain after this. And then we have also defense survey. Defense survey is a bit tricky, because some of the survey data not even though it has been surveyed and also has been collected, but some of the data is not included in the report or in the plot of the plan. So because it is probably because of the defense requirement, they have to hide some of the data. And then thirdly is the geological survey to identify what type of geological plane that we have on the subsurface of the earth, and then a mine survey to identify what kind of the quantity in terms of quantity, volume of the location that we're going to do the mining work. And then geographical survey is basically to see what are the topography of that area, and this is archaeological survey basically to see the archaeological aspect of that area. And then this is road survey. We are trying to we're going to look into this area of survey after this. And then lastly, control survey. Okay, methods of measuring. There are quite a number of methods of measuring distance. And when you talk about measuring distance, it depends on what type of instrument or device that you use to gather the data. And then the works itself, the instrument that you use also will depends on what type of work that you're going to carry out. So for example, if you use a normal ruler, 12 inch, 12, for example, a 30 centimeter ruler, probably you need to use this only when you do the work on the paper. So it's not suitable to use other type of instrument or measuring method to do your work on the paper. So that is how we basically identify what kind of measuring method to be used when we do our work. For example, okay, there are quite a number of measuring method. For example, this one is spacing. Spacing means you just walk from one location to one location. This is normally being used when you carry out the preliminary survey. When you start your survey, you do the preliminary survey. When the accuracy of the data is not so important, but you want to know the distance of certain objects, so you use spacing method. Okay, the other method is odometers, where you basically use your car or your vehicle odometers. You set it to probably to 0. And from that location, you drive your car to the spatial device. And most of the current survey equipment use tachymetry system. And then taping or chaining, I've explained just now. And electronic distance measurement or EDM. This one is also basically it uses tachymetry system as well, but it used electromagnetic wave to measure the distance. And then lastly, global positioning system. This is the latest technology that we use. Probably in terms of accuracy, if we compare between EDM and GPS, some of the GPS system is not it's not that accurate, but it meet the purpose of the GPS system. Okay, we need to know also the sources of error. Basically, there are three sources of errors. One is personal error, when the errors which are introduced due to fault of the observer. If we have a very bad surveyor, we will get basically a very bad data. So secondly is the instrumental errors, the error which arises due to defective calibration of an instrument. Probably because of there are some defect on the measuring equipment. So this type of errors can easily occur during the survey work. And thirdly is natural error. Normally this is because of the natural phenomena of of our world, because of temperature, all this measuring equipment probably gather some certain expansion due to heat or humidity or even gravity. When you try to pull the measuring tape, it's not really straight, and also because of the wind and all these things that can cause natural errors. Okay, the other type of error are measured in terms of measurement error. It is divided into two, which is systematic error and also random error. Systematic error occurred from well understood cause and can be reduced by adopting suitable method. And random errors basically due to combination of causes and beyond the control of surveys. This is where we don't want any survey data to be in this situation. Okay, we're going to type of error. Our Earth surface is basically in a sphere shape. So what we in geodetic survey, the surface of the Earth is considered not in a plane but spheroidal or sphere. So when they carry out the geodetic survey, it requires a very high accuracy. Most of the time, geodetic survey is carried out in the ocean using a special ship, or even using aeroplane. Normally to carry out the survey of a very large area. And what we normally use in engineering survey basically a plane survey, where we consider that the Earth's surface is not in spheroidal shape but as a plane, like the one that has been shown in this. This figure. So as the plane survey extends only as a straight line, and the angle between any two lines is considered as plane angle. Like for example, this one, because we are doing in a very small area. So even though the survey equipment show us on the straight direction to the staff, um, because of the size of the Earth, we consider that we assume that the survey is quite accurate enough for the uses of engineering survey. Okay, now we're going to the most important part of this lecture, the application of plane surveying. Okay, normally when we carry out the plane survey, there are four main area of survey that we carry out. Firstly, it's engineering survey. The whole of these are considered engineering survey, where we try to gather the 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 data of the objects, in terms of the location, in terms of x and y direction. And then we also carry out the cadastral survey, like the one that is shown in cadastral survey, we will choose that private land. We will have to do land acquisition for that location. And then thirdly is topographical survey. As you can see here, there are some kind of we call it contour line that is shown in this plan. The contour line is basically the topographical, what we want to see in the topographical survey, including all the other aspect of that area, like for example the river, if there is any drain, or maybe there is also a lake around that area. This is topographical survey. The data that we want from topographical survey, because when we carry out engineering survey, we got the x and y direction of that data. In topographical survey, we require the z value of that data. Means that it will show us the elevation of that point. And then lastly, the hydrographic survey. In the engineering and topographical survey, we probably can only see the on-land data. So if you want to carry out the elevation of the riverbed or other water bodies, we need to carry out the hydrographic survey. Some of the probably they also call hydrographic survey as bathymetric survey. Okay, in engineering survey, in road construction, we have topographical survey. We include also underground survey or utility mapping, hydrographic survey, and also cadastral survey. Okay, this is the process of road design, road construction, and also maintenance. We'll start with some feasibility studies, where the design engineer or the planner of that road has to carry out the site reconnaissance. During this stage, basically that engineer or that road planner has to identify what is the brief of that project that has been given by the client, and then from that the designer has to carry out the desk study to identify whether that proposed project is is can be carried out on that location. So from that, the designer need to identify certain issues in terms of the alignment that they going to choose, and then the designer also need to do some desk studies on the geographical situation of that area. Okay, and then after that, the design part, it has three stage of design. Firstly, concept design, where when the designer has identified the route to be selected, probably they have two or three alternative routes that they need to consider, and then they will do some assessment on all the route selections, and then will carry out the best. And then after that, they will identify the best route to be selected based on certain criteria. Most of the time, the main criteria will be the cost of that project. Okay, after that, okay, if you can see here, I have a differentiate between the blue sentence and also red sentences. Okay, basically the blue sentences is, the blue parts is to be carried out by the route designer or maybe the route planner, and the rest, the red sentences are basically the stages that has to be carried out by the land surveyor or licensed surveyor. Okay, the first stage, after we have identified the route, okay, this is where the licensed surveyor or land surveyor has to carry out the first stage of the land survey. And then after that, after they finish the land survey work, they will transfer all the data into the land acquisition plan. We call it a section 4 to be submitted to the land office to get the approval of the work. And then from that survey data, the designer will start to do the preliminary design, and then after that, followed by the detailed design. And then once the detailed design has been completed, the licensed surveyor will come again to continue with the to complete the land acquisition plan of section 8. What is the difference between section 4 and section 8 of the land acquisition plan is basically the when we carry out the section 4 of land acquisition plan, it's basically during the concept design. We only freeze the alignment or corridor of that route, but in the when we carry out the section 8 of land acquisition plan, it is based on the detailed design where we have identified the proper corridor of that road, including all the drainage system and everything, and also the intersection of that road. So we will identify what is the final area to be taken from the private land. And then after that, after the detailed design has been completed, it comes to the construction stage where the licensed surveyor has to, or land surveyor has to come back to that project to do the pegging of the center line. And then lastly, the operation and maintenance, the surveyor has to carry out the fine survey, or we call it halus, to to produce the plan acquis as the final land title for the private land. Okay, we will go to the I will bring one case study. This is quite important for you to understand how we carry out the engineering survey for a road project. Okay, this has been taken from road in from a project in Machang, Kelantan. Probably some of you are also from Machang. So you may be familiar with this area. It is close to it is located in Kampung Padang Selisih, and the road basically pass through in front of SK Hamzah 2 in Machang. Okay. Okay, during the site reconnaissance, as I explained before, the designer or the engineer has to carry out the desk study based on it's very simple nowadays. We have topographical map by Geocamp and also Public Work Department by JKR, and also we have other type of assistance which is available online and not only considered cheap, it is free. We have Google Earth, we have also Google Map that we can use that has covered almost 60 to 70% of and EB's geoportal that you can view, but if you require that the plan of that area, you can buy it straight away from the geoportal. And also we have also iPlan Malaysia that we can use to see what are the current usage of that land. Okay, this is the site location of that project. Basically, it is about 2 kilometer to Bandar Machang, and then this is UITM Machang, if I'm not mistaken. This road is basically route from Terengganu towards Greek. We call it Jalan Greek Jeli, route number 4. And then there is another route here, D18. It is a state road. So basically this project to connect between route 4 somewhere here to the state road D18. There is currently a road from Kampung Bukit Tiu here that connect to Sekolah Kebangsaan Hamzah 2, SK Hamzah 2. But the road basically just stop there, and then we want to construct another road from SK Hamzah to connect that road to Jalan Greek Jeli, FT004, this one. Okay, this is the topographical map that we gather from Google Map. And then if you can see here, you can change the layers of the view from topography map that show also the elevation. Like for example, if you can see here, you can zoom in and zoom out to identify what is the elevation of the area based on the contour. Like for example, in this area, you can see there is a different contour. Probably it tells us that there is also a different elevation of this area. It means probably there is a maybe a small kind of mountain, or maybe a different elevation of that land. Okay, if you push this button here, it will change the layers and show us um, the real condition of that area. So these are the important data that we going to use during the desk study. As you can see here, we can see all these the land usage around this area, and if you zoom in, you will see so many kind of data. For example, the existing road, and also the the resident area, the residential area around that area. Okay, this is after we zoom into the area. Okay, as you can see here, this is the SK. Okay, okay, this is this is what always happen when we have online meeting when you work at home. Okay, I'm sorry for that. Okay, this is the school SK Hamzah. This is the existing road. So we're going to construct the road between from this location to FT004 up to here. As you can see, you also can measure distance in Google Earth. You can measure distance. So apparently it's shown here the distance of our alignment, our proposed alignment is about 580 meters. Okay, you can zoom further and see what are other available data. For example, how maybe we need to avoid certain area or certain land that probably will cost us more will cost us more during construction. Okay, this is another view in terms of topographical view of the same area. Okay, from EBIS geoportal, okay, we can see what is the current ownership of the land around that area. Okay, so you can see, okay, this is the existing road. We need to carry out underground survey utility mapping, and also this is the cadastral survey. What is the ownership of the land around this area? Okay, and then there is also data in terms of hydrographic survey. Okay, as you can see here, there are some sort of probably a river or maybe a drain. Okay, this one, as you can see here, this part is basically a topographical survey. If you carry out this alignment, if you plot this alignment on the Google Earth, you can analyze the elevation of Earth. As you can see here, okay, this is the elevation of the alignment that we choose. It shows us, okay, probably there is a two low laying area around this, which if we go to that side, we will identify this as a small river, and this one is a drain, the roads, a very big roadside, right? Which we need to carry out the hydrographic survey. Okay. Okay, after that, after we identify the survey corridor and everything, we will appoint a land survey or license survey to carry out the survey work. in the first stage and straight away carry out the land acquisition plan for section 4. Okay, this will be the route corridor that we choose. We need to carry out along the alignment, and also we need to do the survey around this area, probably about 300 or 500 meters before the intersection, so that we will know whether we require to expand the road. Am I still in the? Am I still in the?
Yes, Doctor.
Can you hear me?
Yes, Doctor.
All right. Okay. Okay. This is okay. All right. Thank you. This is the other part of the survey work on because we are trying to connect the existing road, and so we need to carry out the land survey around the opposite side of the proposed alignment as well. Okay, and then after the licensed surveyor has carried out the survey work, and it will come out with the proper data, survey data, then it will give us the survey data which we can use to do to carry out the preliminary design. Okay, basically there are to carry out the design, we need to identify. Okay, we need to know the type of curve, for example, horizontal curve or vertical curve, circular curve, spiral curve, simple curve, compound curve, and reverse curve. These are the type of curve. Horizontal curve is basically, okay, I'm going to explain after this. Okay, horizontal curve is based on horizontal perspective, where it is so important that we need to identify what is the stopping sight distance of certain object. So if you have a very very big radius of horizontal curve, it will give us more sight distance for the driver to see any hazard that is coming from the opposite direction. Yeah. Okay, there are two types of horizontal curve. No, there are 5 types of horizontal curve. Simple curve. This simple curve is when you connect two straight lines based on tangent to tangent. Okay, we have a very simple curve based on the radius of the circle. And then secondly, compound curves. Basically, it consists of 2 or more consecutive simple curve with a different radius. You have one radius here, and then you have another different radius here. This is compound curve. This is the third type of horizontal curve is reverse curve, which in road construction, current road construction, we not really like this kind of curve because it is can be considered as unsafe curve, because you have to turn right, and then after that you have to turn left in a very short distance, where this kind of curve is considered user. And then fourthly is a spiral or transition curve. Most of there are many horizontal curve that was designed using this kind of curve, spiral and transition. We have spiral curve before we enter to the scalar curve. Okay, and then this is combined or composite curve. Most of the road construction nowadays, especially the main road, we use this kind of horizontal curve, combined or composite curve. As you can see here, there is a transition curve before we enter the circular curve, and then there is another transition curve. So if you drive in this kind of horizontal curve, it is more comfortable compared to the other type of horizontal curve. Okay, I have provided also some notes and also some equation or formula that you can use to carry out the horizontal curve design. And then this is the alignment control plan or ACP of that project. As you can see here from SK Hamza at channel 0, we have two IPs or intersection point to meet that that alignment from SK Hamza to the FT004. So if you look closely, this is where we have the horizontal curve. We use the combination curve with a spiral and then circular and a spiral again. This one and this one. And this is the IP number 2. Okay, and then after that we have horizontal curve and we have also the vertical curve. This is the vertical curve. It is also important because it also controls the side distance of the driver. If the vertical curve radius is very short, probably you have a very short to see the hazard or any object that is coming from the longer vertical curve or radius. You will have a better stopping side distance to the object from the opposite direction. Okay, these are types of vertical curve. If you have crest, normally it's uphill. If you go uphill, you will see the crest. If you drive your car too fast, probably the car will start to fly away across the crest. And the second type is sag, where when you go downhill, you will, and then after that it's combined with the uphill direction, you will feel that your body movement, some sort of push to the gravity direction. It will give us some sort of uncomfortable pressure to our body. Okay, these two types of vertical curves is normally normally we will see in any road design. Okay, after that, from the data from survey data, as you can see here, there are some sort of lines. This is basically the contour lines of that road. These contour lines has been this contour line has been surveyed by the licensed surveyor, and then it gives us the elevation of that area. So this is the elevation of that area. You have identified the alignment, and then after that, from that alignment, okay, I forgot to inform this. This road design has been carried out using the civil 3D application. So from there, we identify the profile of that road from the alignment. And then the second stage, we identify the profile of the alignment. And then we start to identify which one is the proposed level of the route. Okay, to balance out the area that we want to cut and the area that we want to fill. Okay, we cut part of this area and also this area because it's too high to get a flatter route and more comfortable route for this area. Okay, another thing also, it is important, the survey data is very important so that it can be used to identify the volume of earth that we're going to cut or fill for this project. Okay, during detailed design, we use the survey data to identify the drainage system of that road, because it tells us a very important information related to the elevation and how the surface water will run off into the lowest part of the area, and how we are going to manage the surface water. And then after that, we use that survey data also to design the traffic signage. For example, okay, we have the intersection point right here and right here, so that we require certain type of signage. For example, we use chevron to identify there is a curve around this vicinity and so on. Okay, other type of survey data as well. We used to design the traffic measurement at work zone and to identify the stage of construction, which area we need to start the construction first and which one we can do it later based on the topography of that area. And then after that, we also need that survey data to carry out the environmental protection works, because whenever there is a different elevation and we carry out the excavation works, the earth will be left bare without any protection or any grass cover on the earth. So whenever there is rain, the project is subject to the environmental issues such as landslide and everything. So the survey data is so important so that we can design for the environmental protection works. And then after that, it's also important for us to identify the required geotechnical works. For example, in this area, we know that this area we need to fill up with a proper soil. So we need to identify what kind of geotechnical treatment to be used around this area, for example. And then after that, we need to also identify the utilities to be relocated, especially from the existing road, so that we can ensure that all the utilities is not placed under the road. Okay, and then after that, the land surveyor will continue with the land acquisition plan of section 8, because we have identified the final data, the final road design, including the amenities of the road, for example, the drainage system and the the lowest part, the lowest point of the slope and everything. So we can identify the final area that we are going to take from the private landowner, and then after that we can carry out the fine survey or ukur halus during the stage 3. So this is the final final land acquisition plan. As you can see here, this is the lower part of the road. This is the top part of the road, which is FT004. This is D18. Okay, this is the existing road. The yellow part is basically the existing road that has been gazetted as the government land. So we don't have to take this area because it is currently owned by the government. So we need to, because we are going to construct the road in this area. This is the red color shown us the area that we need to acquire from the private landowner. Okay, some lesson learned and conclusion. Okay, can I have another 2 or 3 minutes? Okay. Okay.
Okay, Doctor. Can.
Okay. I would like to share with you, based on our experience out there, there are several companies or contractors. They try to take advantage on us, basically as probably the owner or the executor of the project. We have one experience before this in one of our projects. This is not the one that I just presented just now, not in SK Hamzah, not that road. This is in our other projects. After we completed the design and then we procure that project won by some by a contractor, and then once the contractor start the project, they will start to do the confirmatory land survey of that area. So after that, the contractor declared that there is some problem with the previous design, which they said that the elevation of that area is different from the actual on-site elevation. So they said they need to fill further up. For example, this is the proposed. This is the as you can see here, the rough lines is basically the original ground level based on the design, and then the designer has come up with this smooth line as the proposed road line. So based on the contractor said that basically what happened on site, there is a difference between the on-site elevation about 1 meter. It means that basically the original ground level is 1 meter below the original ground level. So they ask for variation order or additional volume of earth to be filled on that area. So if we just agree to the proposal of the contractor, even though it's only affected only affected 1 meter of the elevation, you just imagine if this road is about 1 kilometer. So how how big is the volume that we need to fill. Probably we need to import from some other places to cover this project. So it will cause the even though it is only about a few centimeters, it will cost us very big if we consider the length of that road. There is another situation also, as you can see in this example. The contractor, okay, the design came out like this. There is a straight line, and then after that there is a curve towards the end of that road. And then after, basically, as you can see here, there is a line that shows the end of the slope around this area. So basically, if the road extends further, the road will fall under the slope, and there are a lot of earth we need to fill around this area to make sure that the platform of the road is properly seated on that embankment. So the design came like this, just before the end of the slope, and it's supposed to be a good design. But however, the contractor is so clever, they extend about 1 meter beyond the proposed starting change here, about 1.5 meter only, not even 2 meter, about 1.5 meter. So in the end, the whole curve fall beyond the embankment or the slope. So the effect of that extension of 1.5 meter, you see, the contractor has proposed that they need some variation order around this area in terms of imported earth material to cover the additional requirement of earth around this slope. So this kind of act also will cost us a lot of money if we are not properly check the real situation of that site. So this is why it is very important for engineers to really understand how the engineering survey work is carried out on site, and also in terms of the theoretical aspect of the survey. So I'm coming to the last slide of my lecture. The conclusion is engineering survey is an important element of a construction project, and a sufficient fund needs to be allocated for engineering survey. Sometimes we
Okay guys, hang on a while.
a very small amount of did I?
Doctor? Okay,
Alright.
you're already in. Okay.
Do you miss which part did you miss?
The first point.
The first point, okay. Okay, for the conclusion, it's very important for us to, okay, engineering survey is an important element of a construction project, okay. And then secondly, we need to provide sufficient funds to carry out the engineering survey, because some of the project, if we try to save the the project budget, we will gather a very limited survey data, which is not sufficient to carry out the engineering design. And then lastly, the accuracy of survey may avoid any unnecessary additional costs, like the example that I just shown to you before this. Okay, with that, I think that's all from me for this lecture. I'm sorry to take more than the required time
It's okay,
available
Doctor.
for me. All right.
Okay.
Do you have any question?
Yeah. If student have any question, you can unmute your mic in the Google Meet, and for the YouTube live, you can post your question at the comment section. And Doctor, while we waiting for the question, can you share a bit about your experience after you got the survey data, like for the construction process? How to do after the engineer got the survey data?
Okay. Normally, what we did is we need to go back to that site to verify that data first. It is very important because we have many experience that the survey work has been carried out very badly. I can say very badly, because whenever we have a project, the survey timeline is a very crucial time. We provided the licensed surveyor only a very limited time. For example, if we have an experience that we have 50-kilometer routes that the surveyor need to carry out the survey within only 5 weeks. So it is important for that licensed surveyor to plan their survey work by probably providing more teams. And the problem is when they have more than one teams, it is very important for the licensed surveyor to do some calibration between all the survey teams, so that we will get the most accurate data. Okay, there is for the verification of that work, and then after that we will start to import because normally the survey data came in AutoCAD version, so the data can be imported into our design software. We have a couple of design software for road, for example, Civil 3D, one of the largest user in public work department in JKR, And then other than that, we also have MX Road, and also I don't remember the other. I'm not very familiar software. So these are two main software that we normally use. One is Civil 3D. It is also part of the AutoCAD version, and then the other one is MX Road. Both software can read the AutoCAD data that has been provided by the licensed surveyor, and then from that we can carry out the the road design based on that survey data.
Um, okay, Doctor. So another question. What did Dr. Azwan mean by poor survey data? How to indicate the data is poor?
Okay, because every time we carry out road construction, we have lined up certain terms of reference for the licensed surveyor to carry out their survey work. In that terms of reference, or TOR, we identify certain things that the licensed surveyor need to capture in their survey work. It's not only the location of the item or the objects in terms of X and Y direction. They need to identify the Z direction or the elevation of that point as well, of that object as well. That's one thing. And then some of the licensed surveyor, they tend to um, to capture the data from a very big gap. For example, we the best gap to capture certain data, for example, the land elevation, and also the land elevation basically between the area of 1 meter or 2 meter apart. I mean the gap of each point. So they need to carry out every 1 meter of that area along that. For example, okay, I can show you probably in that. For example, if we have identified this area as the area that the licensed surveyor need to carry out, they have to carry out the elevation survey every 1 meter of this area, the whole area. Some of the licensed surveyor, they just skip that. Probably some part they make it 1.5 meters, some part they make it 2 meters. So we lost the accuracy of that area. And then, for example, as you can see, this area, if I try to zoom, can I zoom? Okay, for example, this one. Okay, can you see? Okay, for a drawing of the existing box culvert, the wing wall. It's not very clear because this is not as sharp as the real data. Okay, the licensed surveyor need to also indicate this kind of objects in the survey data. So they need to identify where is the existing culverts, how is the drain, this is the drain and everything. there are so many uh, data they need to gather from that side. So some surveyor, they tend to left out all these details. So we need to go back to that side to verify whether they have included everything. And then after that, we need to ask them to probably redo the the the, the drawing that they have plotted, or probably there are certain time also they need to do the survey work again. All right, is there any, I hope that answer the question.
Okay, Doctor, thank you for the very useful answer. I have another question. Okay, so as we know that survey, as example for the topographical survey, and by the meantime, macam mana, permukaan bumi akan berubah. So adakah survey tu akan dijalankan, akan ada renew untuk map tu apa semua? Dalam masa berapa tahun ke apa ke, macam mana nak detect perubahan permukaan bumi tu?
Okay, that's topographical survey. A regular topographical survey are normally carried out by Japan. They will come out. They will come out with some sort of plan like this. Even they have a topographical survey for each state and also each district in Malaysia. And then they carry out this mapping regularly, but they will update for each district probably between 10 to 20 years. Yes, there is some sort of changes to the existing topographical information because of changes in the our environment itself. So for this kind of topographical data, we can only use for the design concept of a project. We can use this for detailed design of a project. For example, if you want to plan for a road or you want to plan for a highway, you can refer to this kind of data. So after you identify the concept of that design, the design concept, or probably the proposed alignment of that road, then you need to carry out the detailed design, which will tell you the more accurate topography of that area based on the current situation. And even though we have carried out the detailed topographical survey, sometimes between the survey work and also the construction work, it will take probably about 6 months to 1 year to kick off that project. Sometimes there is also a little bit changes to the existing existing topography of that area. But in terms of a project implementation, that will be not a very big issue. Probably they will still incur some variation, but that is very little amount or very limited.
Okay, Doctor, thank you very much for all the information and the sharings from the morning till now. And I hope that the student will take note all of the sharings, because it is important for us to be engineers soon. Okay, so Dr. Azwan, thank you very much for spending your time with us. Okay. Can we take a picture before we dismiss?
Yes.
For this briefing? Okay. Who can take okay, Dr. Nazira?
The presentation.
Okay.
Dr. Sazwan, I'm Dr. Nazira. Actually, we meet here. Okay, face to face. Nice to know you,
Alright,
Dr.
I understand.
Sazwan.
Yeah, thank you very much for inviting me. It's a pleasure also for me to share this knowledge with the future engineer. I hope one day I will see some of you in public work department. InsyaAllah.
Doakan kami, Doktor.
InsyaAllah, insyaAllah, insyaAllah.
Thank you so much. I hope we can keep in touch after this, Dr. Azwan. Actually,
InsyaAllah,
we need people like you to motivate and give a real example for our students. Thank you so much. Okay, so
yeah, I can see a bright future in front of me.
Amin, amin ya Rabbil Alamin. Okay, so are you ready guys to take a picture?
Okay, okay. Betul-betulkan tudung, betulkan rambut. Okay. Kau ada biskut-biskut ke tepi bibir ke? Okay. So, can anyone take a picture? Achan? Achan, are you there?
Yeah, I'm here.
Okay.
Okay.
Kan?
Dah buka kamera. Okay, senyum. Senyum. Formal. First, we are going to formal pose. Okay, senyum. 1, 2, 3. Okay, start now.
Dr. Azwan, there will be
Everyone.
350 watching us in our YouTube.
Oh, I see.
Yeah.
Okay, let's go for gaya bebas.
Okay.
Okay, 1, 2, 3. Okay, done.
Alright.
Okay, thank you so much.
Alright, thank you very much. I wish all of you good luck in your future endeavor.
Give a big applause to Dr. Azwan.
Sorry? Alright, thank you very much.
Okay,
Thank you very much.
clap.
Alright. Bye-bye.
Bye-bye, Doktor.
Okay, guys. So, how you guys feel today? Today after that. After this. Sorry.
Okay.
Okay, semua okey lagi? Semua okey lagi? Okay, respon boleh? Tak dengar suara lah. Tak dengar suara.
Okay.
Alhamdulillah, okey lagi.
Okay saja.
Okay, yang di YouTube okey?
Muka Alia. Barulah saya suka, happy. Yeah, no izin. Tengok langit, tengok apa tu.
Okay, yang di YouTube okey? Okey ya? Saya harap semuanya okey. So, untuk kita untuk kita kembali bertenaga begitu. So, saya nak jemputlah instruktor kita untuk main game. Macam semalam, tapi bukan game yang sama. Okay, saya nak jemput Ama. Okay, untuk sesi break kita. Okay, Ama, the floor is yours.
Okay. Okay, selamat pagi semua. Good morning. Good morning everyone.
Selamat pagi.
Okay, sebenarnya saya tak buat game, saya buat exercise. Saya tak main game, saya exercise je. Okay, so I will do a light workout bukan workout yang berat-berat lah. Okay, just sebab pagi tadi saya ada baca ramai kata sakit bahu. So saya dah praktis bahu ni dah dekat 22 tahun. Saya praktis pada kecil. Okay, so I hope that you guys can follow my arahan. Okay, alright. Boleh? Semua boleh? Kalau boleh cakap boleh. Tulis boleh ke? Okay.
Boleh.
Okay, nice. Okay.
Tak boleh.
Okay, saya settle sebenarnya sebab jarang orang tengok saya ni. Okay. Okay, first exercise is just move your shoulder upwards. Angkat bahu serentak, okay? Okay, like this. Macam ni je. Macam korang selalu buat time lecture tanya. Okay, buat 10 reps, okay? Okay, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, nampak geli pula tengok korang ni. Okay, second, kita buat ke depan pula. Bahu gerak ke depan pula, okay? Like this, macam ni. Okay, boleh? Okay, let's go. Exercise start now. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, now move your shoulder backwards pula. Bawa ke belakang. Okay. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Now gerakkan kanan dan kiri pula bahu. Macam ni. Okay, boleh buat. Kalau boleh cakap boleh guys. Boleh ke tak buat guys? Boleh ke tak boleh?
Boleh.
Okay, boleh. Okay, proceed guys. Let's go. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, I think we need to spice it up . Saya rasa macam tak best . Saya rasa kena letak lagu lah baru boleh. Boleh tak guys letak lagu? Boleh tak guys? Kalau boleh cakap boleh guys. Kita buat like Zumba.
Boleh. Go.
Zumba, okay? Online Zumba, okay? Alright, okay, ready? Kalau ready cakap ready guys, okay? Malunya aku.
Ready.
Okay, let's go. Kita buat semua exercise serentak, okay? Anak-anak TikTok, yeah! I know you want me. You know I want you. I know you want me. You know I want you. Okay, ke depan lah. Okay, kiri kanan. Okay.
Isat tu ketawa pula.
Okay, saya rasa itu sajalah sarapan ringkas saya.
Isat ke minum air tak?
Okay. Saya rasa korang semua dah bersemangat, okay? Okay tak? Semua okay tak? Boleh kecap tak? Kalau okay cakap okay.
Okay
guys.
Cukup lagi. Kita nak Zumba lagi.
Nak Zumba lagi.
Let's go Abang.
Okay, disebabkan okay. Disebabkan ni kita baru menang pingat semalam. So semalam saya ada praktis satu tarian lah daripada lagu ni. Lagu Gemuruh Jiwa. Boleh guys?
Mantap.
Ini typical lah. Typical camp mesti ada benda ni lah.
We want more.
Okay guys. Korang boleh follow guys. Okay, sekejap Mana tadi? Saya ada tengok tadi kat YouTube. Okay. Okay, follow me, okay? Follow me, okay guys? Lagu Gemuruh guys. Aku come on.
Okey, permintaan dalam YouTube ni saya nak slide ni lebih panjang. Okey.
Okay. Okay, I think itu sajalah kot. Okay, sebab saya dah penat lah. Okay. Okay, thank you so much guys. Pada semua.
Thank you.
Makan Kak Amar.
Okay, jangan lupa exercise sehari, okay. Makan yang bagus. Okay, nanti korang akan dapat badan yang baik. Okay. Okay, thank you so much.
Okay, Amar, lepas ni we are going to invite you, Amar, face to face.
Boleh. Next time. I will do my best. Okay.
Okay, thank you.
Alright.
Okay, saya nampak di dalam YouTube pun dah happy. Okay, masing-masing minta apa kami kat YouTube perlu buat apa ni. Amboi. Menarilah. Okay, right. So kita tunggu. Okay, tarik nafas masing-masing lepas ni siapa jadi MC Aiza?
Oh, saya lagi.
Masih Aiza. Okay.
Ya, saya lagi.
10. Okay, kita nak you all boleh take 10 aku. 10 Okay, sebab 10.30 kita akan mula. Boleh semua. So boleh get refresh. Tak payah keluar lah. Tak payah keluar dari platform. Okay. Just tutup video, tutup suara, pergi ambil refreshment, bangun and then come back. 10:30 sharp. Okay, our invited speaker akan join kita. Okay, clear?
Assalamualaikum.
Salam Dr. Mus. Okay, Dr. Mus mesti ada benda nak cakap tu. Silakan Dr. Mus.
Okey, Assalamualaikum. Selamat pagi semua. So, saya harap semua dah dapat nombor grup Grup kumpulan dah ada kan? Semua dah ada kan?
Sudah, Doktor.
Okey, semua nama-nama tu adalah dipilih oleh SESI. SESI yang pilih bukan saya So, SESI tu menggunakan AI teknologi. So maksudnya tak ada komen, tak ada apalah. Dia yang pilih sendiri. Dia dah tengokkan awak punya nombor matrik, awak punya nama. So dia dah buat prosesan, memang satu malam dia proses and then pagi ni keluar come out dengan nama kumpulan-kumpulan tu semualah. So tak ada yang nak komen-komen lah. Maksudnya memang fair and square. So tak ada saya kata dia ni kawan baik dia ni kawan baik dia ni, tak ada. So semua sistem yang buat. So semua kumpulan dah ada. Ada kumpulan yang 6 orang, ada kumpulan yang 5 orang. Paling kurang 5, paling banyak 6. Tak ada 7, tak ada 4 So okey, lepas ni awak akan bekerja melalui grup ni. Dan kedatangan pun kalau boleh mengikut grup ni. So kalau ada apa-apa questionnaire atau apa-apa pun akan melalui grup yang ini. Okey. Satu lagi, sekejap lagi saya akan masa talk yang seterusnya nanti, saya akan distribute satu questionnaire. Sebenarnya ada 3 questionnaire. Questionnaire ni sepatutnya saya buat sebelum ataupun hari pertama pagi-pagi masa awak pendaftaran semalam. Because ini questionnaire ni adalah kita nak tahu awak punya level of entertain terhadap subjek geometrik. So maksudnya pertanyaan-pertanyaan tersebut dia akan tanya adakah awak pernah menggunakan peralatan ni, adakah awak tahu what is a geometrik. Itu sebenarnya untuk yang orang kata dia punya survey ni, kita panggil dia enter survey. Sebelum you masuk the course, kita kena tanya you apa yang you tahu. You kena jujur lah, you kena jujur and then you jawab kat situ. Seolah-olah awak belum dengar lagi apa-apa pun tak limat daripada siapa-siapa. So itu adalah untuk enter survey punya apa ni, questionnaire lah. Kemudian nanti bila you habis saja camp nanti pada hari yang terakhir, pada 14 bulan, saya akan distribute satu lagi, kita panggil dia exit survey. Exit survey ni adalah survey yang sama juga, question yang sama, dan kita nak tengok part mana yang ada improvement terhadap you all semua. Because sebelum ni kita gunakan F2F, jadi sekarang ni online, jadi kita tak tahu awak punya pendapat, apa awak punya opinion tentang kita punya camp ni lah. Sebab Dr. Nazira pun dah beritahu, camp yang kita buat ni adalah the only one camp yang buat online. Jadi orang kat luar tu tengah observe kita punya cara lah macam mana kita buat. So kita akan improve daripada masa ke semasa lah. Tapi saya harap untuk the next camp mungkin kita dah boleh face to face lah. Saya berharap lah. And then lepas tu saya ada satu lagi survey, kita panggil dia journal survey. So journal survey ni adalah secara keseluruhan lah. So nanti kita akan bagi 3 kali survey lah. So awak jangan orang kata kan, jangan orang kata macam alah banyak sangat survey lah, itu lagi nak buat ni nak buat kan. Tak apa. Itu orang kata dah jadi normal. Awak kena buat benda tu. Kalau ikutkan setiap kita punya talk tadi tu, talk dari semalam, pagi ada 2, kemudian petang ada lagi, pagi tadi pun ada. Setiap talk tu sebenarnya awak kena bagi respon. Bagi dia punya survey tu, maksudnya awak suka tak suka. So benda tu kena ada sebenarnya, tapi kita tak buat lah kan, kita buat. Tapi yang untuk camp kita secara keseluruhannya kita buat. Kita kena ada apa ni orang kata, pendapat daripada awak lah. So semua tu awak kena buat So bila saya arahkan benda tu, so awak buat. Ya. So attendance sampai petang ni saja. Saya akan buat by group. Selepas tu malam nanti dan seterusnya sampai 14 bulan is depend on your supervisor sendiri. Kan? Mungkin contohnya kalau saya lah, sesi saya mungkin akan mula besok pukul 10 pagi contohnya kan. Kalau supervisor lain mungkin 7.30. Kalau Dr. Nazirah 6.30. Jadi terpulang pada diorang lah jadi terpulang pada supervisor masing-masing lepas ni. So katakan malam, saya katakan nak buat perjumpaan pukul 11 malam sehingga pukul 12. So awak ikut je lah. Sejam sahaja contohnya. Tapi kalau biasanya Cik Karun Nizam, dia nak buat pukul 7.30 sampai pukul 11. So awak follow lah dia. 7.30 sampai 11. So macam tu lah. Ini lepas ni terpulang pada supervisor masing-masing yang handle every section. Untuk yang sekarang ni awak masih lagi follow apa yang kita dah planning lah. See? So okey, rasanya itu je kot yang saya nak bagi tahu. So lepas ni saya akan shoot, saya akan bagi link tu pada Dr. Nazira dan Dr. Nazira akan distribute pada setiap group lah. Kan? Sebab kalau saya masuk dalam dalam Meet ni ataupun dalam YouTube, kadang-kadang benda tu tertinggal. Sebab banyak sangat mesej kan. Jadi kalau boleh kita masuk dalam WhatsApp group lah setiap kumpulan supayanya nanti kalau nak cari boleh jumpa balik. Okay. Okey, itu saja. Terima kasih. Okey, bebel je Dr. Mus ni
Okey, terima kasih Dr. Mus. Okey. Semua pun dah tahulah kalau Dr. Mus dah sampai mesti ada benda Dr. Mus nak bagi tahu. So kita pun dah dengar. Okey, take 5 semua. Saya nak pukul 10.30 semua dengan energi yang memang superb. Okey. Take 5, nanti kita datang ni balik mula. Ini adalah last taklimat akhir kita. Taklimat akhir. Okey. Alamak Izzati, kenapa kepala dah senyek? Okey, sementara tunggu ni Alia okey? Jangan nak tutup.
Tak tengok korang.
Okey.
Okey, semua boleh bercakap. Kuarto. So, boleh tak sepanjang kita dah 2 hari, after this, seperti yang kita dah maklum after this kita dah tak ada macam ni dah. Okey, tak semua orang dapat tengok muka saya, tak semua orang dapat dengar suara saya lagi. Okey. Memang rasa wow, bersyukur tak dengar suara Dr. Nas. Okey. So, ada apa-apa nak tanya tak? Okay? Ada apa-apa nak tanya tak? Ataupun ada apa-apa yang you rasa we need to do in this type of camp? Boleh je. Daripada selain daripada you dah masukkan dalam Google Form yang akan diedarkan oleh Dr. Mus nanti, you may share here. Better you cakap direct kan? Kuato, apa yang you rasa dalam camp ni?
Okey lah, saya boleh form apa yang lecturer terangkan lah. Setakat sampai semalam hari ni dapat faham lah.
Okay, I mean you rasa ralat tak? You tak dapat pergi face to face. Okay, Alia dah mengangguk rasa ralat. Okay, wait Alia, after this I go for you. Okay, you Kuatong, you rasa ralat tak? Ataupun you rasa okay?
Lecturer tanya saya.
Ya, saya tanya.
Tak. Saya rasa tak pergi camp secara face to face agak satu kekurangan lah. Sebab berhadapan dengan wabak COVID-19 lah. So kita terpaksa buat online. Mungkin kita tidak dapat perasaan suasana yang berada dalam real camp sebenar.
Okay. So suasana camp yang kita
yang sebenar secara face to face. Mungkin kita tidak dapat berkomunikasi secara face to face. Berkongsi pengalaman.
Okay. Alright, so Alia pula. Alia tadi cakap, cepat.
Saya nak cakap apa, Doktor?
Alia cakap tadi macam ralat dia tak dapat pergi face to face kan?
Sebab saya tak pernah pergi camping.
Okay guys. Kalau in term of keseronokan yang awak nak rasa, orang kata pegang alat, berada di tengah panas, dapat rasa mandi hujan, terpaksa berhujan, okay? Itu memang anda tak dapat dalam online. Betul, tak dapat. Okay? Tetapi apa yang perlu anda sebagai civil engineer tahu, anda akan dapat dalam online. Okay? Macam tadi talk daripada Dr. Sazwan, kalau awak faham betul-betul word yang dia sampaikan, data ukur sangat-sangat penting untuk pelaksanaan projek. Okay? Dan untuk civil engineer memahami data ukur adalah sangat-sangat penting. Kenapa? Sebab kadang data yang diberi tidak menempati spek untuk pelaksanaan projek-projek tertentu. Ingat tak? Ada recall tak? Ada recall tak semua? Mana suara? Lemah dah ni. Mana suara? Okay, ni Alhila. Ya, betul ada. Lagi?
Doktor.
Ya.
Doktor, saya nak cakap satu lah.
Okay, silakan.
Jadi, sebagai saya tak nak cakap yang saya penghulu. Saya tak nak cakap sebab saya rasa kita sama-sama bekerjasama. Tapi sebab saya dah diberi mandat, saya sangat-sangat berharap untuk semua pelajar agar menjaga tata tertib budi bahasa anda dalam online. Faham tak? Kalau awak rasa awak sangat savage tapi bukan kat sini, this is platform where we need to get some knowledge. Faham tak? Jangan macam ni. Bukan, maaf saya cakap. Saya perasan dari semalam lagi, banyak sangat mulut-mulut yang cakap itu, cakap ini, cakap itu, cakap ini. This is the first online. You need to understand. Bukannya bahagian management atas pun ada permasalahan-permasalahan. Bawah sendiri pun ada permasalahan-permasalahan. Jadi anda sebagai pelajar tolong faham. Okay? I don't want to blaming you, but this is melampau lah. Korang semua dah degree. Everyone is 20 above. 20 dah boleh berfikir. Betul tak? janganlah. I don't, sebab faham. Sebab okey, kalau doktor tak nak, mungkinlah doktor rasa risau nak ni, tak apa, saya boleh cakap doktor. Sebab saya rasa benda ni is too rude lah. Sebab kita ada pencerahan luar. Korang nak cakap aku apa bila aku cakap macam ni, aku tak kisah. Korang cakap aku ni ikut ke apa, tak kisah. Sebab sebagai pelajar pun mungkin aku ada rasa bahawa kita punya management mungkin adalah, ni biasalah, we are people, right? Dengan COVID macam ni, kita fahamlah antara satu sama lain. Okey, janganlah ikutkan perasaan anda. Semua orang merasa bahawa cuti, ada camp, mungkin ada something yang, tapi please lah, please, tolong. Sebab kita patut ada juga lecturer yang tengok perangai-perangai anda. Markah awak boleh terjejas. Tolong jaga, itu je. Saya minta, harap-harap untuk jaga manners korang. Okey, sekian, terima kasih. Assalamualaikum.
Okey, terima kasih Hacan. Okey, sebenarnya okey, apa yang disampaikan oleh Hacan tu adalah suara benar yang beliau rasa bila melihat komen-komen. Okey, itulah sebenarnya apa yang kita perlu ni. Mungkin ada yang kata tak berani terima komen negatif. Tak. Tidak juga. Tidak. Anda berhak beri komen. Anda berhak menyatakan apa-apa. Cuma sebelum melontarkan sesuatu, tenang, fikir, dan baru maklumkan. Boleh? Okay, so Acan, are you okay there?
Saya okey.
Okay, saya okay. Selepas ni kita dah bersedia semua dah bersedia. So platform kita okay. Azizi di YouTube okay. Okay. Untuk pengetahuan semua saya maklumkan di sini. Memang tim pelajar yang saya sendiri sebenarnya tak kenal. Mereka volunteer untuk membantu saya honestly saya tabik satu tangan tak cukup, saya tabik dua tangan. Thank you so much team yang set up this platform to me. Okay. Back tadi kita doa sama-sama. Saya pun harap ini adalah camp yang terakhir kita buat platform macam ni. Okay, terakhir. Okay, so saya nak invite kita punya speaker. Boleh saya dengar suara? Dah okay belum?
Okay.
Okay, MC, are you ready?
Yeah, I'm ready.
Okay, MC, you boleh mencelah-celah sikit tau. Talk daripada ni The rest also support lah kita punya MC ni last session ni. Okay, saya dah tengok Mr. Sazwan dah get in ke belum? Okay, wait. Mr. Sazwan. Okay.
Assalamualaikum.
Waalaikumsalam. Yes, Mr. Sazwan is here already. Alhamdulillah. Okay. MC, the mic is yours.
Alright. Okay, so we will start our last briefing. Okay, so the last briefing is about the geomatics in the offshore industry, an overview for a civil engineer perspective by Encik Muhammad Shazwan Kamil bin Abdullah. So like usual, I will introduce a bit about Encik Shazwan. So Encik Muhammad Shazwan Kamil bin Abdullah, his work experience 16 years. And he was a senior geotechnical engineer from March 2014 until 2020 and continue as a staff engineer in geotechnical since then. Okay, from 2020 until now at Petronas. So without further ado, the floor is yours, Encik Shazwan.
Thank you Miss MC. Boleh dengar saya?
Boleh.
So Assalamualaikum and a very good morning to all of you. First of all, I thank you to UTHM, again to Dr. Nazira for inviting me. I think this is the third session lah, after the previous two sessions. I think in May, May or June. That's April, yeah.
In April.
So for the last April, two sessions. So this August is one session. So it is actually an honor lah to me to be a presenter and also to share my experience, my bit knowledge on the geomatics as a civil engineer. So so without any further ado, I will share my presentation for today. Nampak ke my slide?
Nampak.
Nampak Encik, nampak.
So today we have how many participants today?
507.
507, wow.
Yes. As your information, Mr. Sazwan, in this platform we have 92 participants, including you. But in streaming YouTube online, we have 364.
Oh,
live.
okay. Tapi tak dapat tengok kat sini lah ada the viewer daripada YouTube and other platform tu tak just counting kat sini.
Okay, I will share you the link. But now we are live, Mr. Sazwan, we are live. So kalau ada soalan daripada platform tu memang akan ada, kita punya MC akan maklumkan Mr. Sazwan.
Okay, baik. So again, so this presentation is for program of amalan kejuruteraan geometrik, pelajar sarjana muda kejuruteraan awam UTHM. So the title of my sharing today is the importance of understanding for the field geomatics for civil engineer. So my presentation outline today is I will touch a bit on my biodata, who am I and what I do now. Before this, our Miss MC already briefed a bit on myself, thank you. And then we touch a bit on the objective of our session today. And then I will share the offshore oil and gas development chain, a bit overall ataupun the general understanding of the development chain in offshore industry. And then geohazard and seabed features hazard. So we're going to touch a bit on a bit on the technical for the geohazard and seabed features hazard. And then I will elaborate further on the geophysical survey background, and then offshore soil investigation. And then we're going to jump to the field of geomatics, what geomatics relating to our civil engineer role. And then the importance, I think the most important slide that I will share today is the incident ataupun the consequence from the role ataupun the importance of this geomatics, which is reflect to the incident due to underestimation of the field geomatics. And then I will, at the end of the session, I will conclude our session today. Okay, as mentioned by Ms. MC, I'm a staff engineer, specifically ataupun specialized in geotechnical in Petronas. Basically, I was in group technical solution ataupun we known as GTS in Petronas. Overall ataupun my overall experience is about 16 years since I was graduate from UTM, University Technology Malaysia, back in 2005 in civil engineering. And then I was involved first in petrochemical plant construction for about 3 years. And then after that, back in 2009 ataupun 2008, last 2008, I was first joined the offshore soil investigation company, which is mainly they are doing the geophysical work as well as geotechnical work ataupun kita panggil soil boring in offshore. So then I spent in that company, which is named as Offshore Works Sdn Bhd, for about I think about 5 to 6 years in offshore work, which is in that company I was given the opportunity to gain my experience and knowledge basically as a geotechnical engineer. So I was on board a few geotechnical vessels. So I was perform a duty ataupun as a geotechnical engineer as well as the party on board at several countries, basically in South Asian region, Indonesia, Malaysia mainly, Sabah, Sarawak, Thailand as well, Vietnam, and a few other South Asian countries. And then I was involved juga in geophysical survey campaign. So also in Malaysia and also in South Asian punya region, and I was give the opportunity to learn a new technology about the geophysical industry, which is on the autonomous underwater vehicle AUV in Norway. About I was there about 4 months to train and conduct some testing and trial for that AUV. And then in 2014, I was joined Petronas, also as a geotechnical engineer. So mainly in Petronas, I was give a role as ataupun focusing more to onshore instead of offshore now. So I'm doing more on the geohazard risk assessment.
Mr. Sazwan?
Yeah.
Can you make it as a presentation slide? Because it's too small for us.
Oh, okay. The view is a presenter view, right?
Is it presented? No, it's not presentation slide. I mean the PowerPoint.
Yeah. So
Can you make it as a presentation mode?
Memang saya dah share as presentation mode. Tak apa.
No. Dalam PowerPoint tu, but here we cannot see. We still can see it's not in the presentation mode.
Okay.
So
Let me share again.
oh, okay. It is. Wait.
Nampak? So now I minimize balik. So
It's not working.
is it a full slide?
Nothing changed, Doctor.
Means masih kecil
Ya, masih kecil.
I try to reshare again. Stop sharing. Kalau macam gini, nampak full screen ke?
Nampak.
Ya, nampak.
Baru full screen. Oh, okay. Okay, sorry. So kat mana dah tadi? Sorry. Currently I'm more focusing on the onshore task, which is on the geohazard risk assessment for onshore facility ataupun asset for Petronas. Sometimes also conduct a few assessment also offshore geohazard site investigation campaign. That is what I'm today. So again, the objective of my presentation today is to demonstrate the importance of understanding of the field geomatics based on my relevant experience, mainly in offshore geohazard site investigation campaign. So sometimes mungkin kalau yang biasa baca ataupun pernah mengikuti any sharing ataupun presentation daripada a real geometric punya engineer ataupun personnel, so mungkin a bit different with my presentation because I look into a perspective of civil engineer. Okay, so maybe a bit high level ataupun a bit surface, not too detailed into technical, I can say. So Dr. Nazira, if you may add ataupun you want to like to comment anything during my presentation, yeah, please. Mana tahu kan Dr. Nazira can also share ataupun correct me on related to geometrics punya term ataupun technical point of view, mana-mana yang silap. Okay, just highlight. No problem.
Okay, Mr. Sajwan. But so far, I've been going through your slide. It's definitely on the track. Thank you so much.
Okay, so we go for the first slide. What is offshore oil and gas development change? So the performing of ataupun the performing of geohazard site investigation campaign during exploration and development phase in green or brown field. So you all pun nak tahu sometimes apakah dia punya workflow ataupun chain, dia punya proses untuk kita sampai kepada development ataupun construction of the platform dekat offshore. So basically in development change ni kita ada four main punya proses, which is satu adalah exploration, kemudian development, execution, and then life of field. So execution tu maksudnya construction untuk develop the hydrocarbon production via manned ataupun unmanned platform. So kalau adik-adik pernah tengok the platform, so that was in third phase execution, dan juga life of field ataupun operation. So bila kita start untuk produce the oil and gas ataupun kita punya minyak dan gas ni, so that was in stage 4, in operation, so we call it as life of field. Basically kemudian on the green or brown field ni, so green means the area that nothing development has been conducted, ataupun kawasan tu memang kosong ataupun tanah lapang di offshore tu, tak ada any development lagi. Kalau refer to brown field ni adalah area yang dah been developed ataupun dah ada been install the facility, contohnya dah ada pipeline, dah ada platform, that area. So that we call as ataupun known as brownfield. So compare green and brownfield ni, it is more challenges kalau kita operate in brownfield lah, sebab we are dealing a lot of hazard ataupun seabed features ataupun structure features at the seabed, which is we cannot see from our naked eyes. So for the geohazard site investigation, it is actually divided by two. First is via conducting geophysical survey. Geophysical survey via conventional survey ataupun using nowadays the industry start to using the AUV ataupun autonomous underwater vehicle. And then after we conducting the geophysical survey, and then the result from the geophysical survey already in order, and then we will mobilize ataupun kita akan continue with geotechnical soil investigation ataupun soil boring. So in this stage, a geotechnical engineer on board, biasanya it is a civil engineer lah, macam saya. So I'm a civil engineer. So I become a geotechnical engineer on board. Kalau dulu first I was on board the geotechnical soil boring atau soil vessel ni adalah I will be a lab engineer. So who receive the sample from the seabed, freshly from the seabed, I will extrude the sample, and then I will start to cut the sample. Nanti you all, I will show you how the samples look like that we bring from the offshore, which is it is a similar shape that we bring for onshore juga using the macam SPT punya tu kan, soil boring. But offshore ni kita tengok nanti, especially in Malaysia region, especially in peninsular Malaysia region, the soil dia punya shape tu sangat cantik. It is purely clay. I can say it is more than 70%. It is a content of clay, and then silt ataupun we known as silty clay. So nanti I will show you the photo how it looks like. And then after we completed the geotechnical soil investigation dan juga geophysical, kita akan come up with a report to allow the next stage, which is the Geocamp rig coming to drill ataupun to explore the hydrocarbon. So basically this stage ni we can say it is dalam stage so-called exploration. So masih lagi dalam the phase tadi, kalau kita tengok the development change tadi, it is masih lagi dalam phase exploration. So our duty ataupun the geotechnical duty ataupun geophysical duty adalah untuk to ensure the safe execution ataupun rig move to the intended location to perform the hydrocarbon drilling, which is via Geocamp rig ataupun submersible rig. Di Malaysia ni kita biasanya pakai this type of Geocamp lah, which is Geocamp rig. Kenapa dia nama dia Geocamp rig? Because because dia ada kaki. So bila dia sampai ke intended location, dia akan lower down dia punya leg. Kalau kita tengok ada 3 Geocamp leg. So dia akan lower down and dia akan jack up dia punya hull. Dia punya ni kita panggil hull. Okay, dia punya platform kita panggil hull. So this is the drilling rig. So ini drilling rig untuk geotechnical vessel. So ni adalah drilling rig untuk Geocamp. So they are drilling for the hydrocarbon, whereas geotechnical is drilling for the soil. Okay. So sometimes juga ataupun kita juga drilling bukan hanya untuk Geocamp entry, tapi for the purpose of installation ataupun the design of this platform. Okay. And then after the completion of the Geocamp rig ataupun drilling, hydrocarbon drilling, we akan move to the next stage, which is development, whereby dalam development ni ada stage feed ataupun front end engineering design, detail design, kemudian barulah construction. So, construction untuk install the platform. That is the roughly punya sequence lah. So why we do this? Why we do this geophysical survey dan juga geotechnical soil boring ni? Why? Mainly it is to minimize the risk ataupun the risk to harm to any personal ataupun equipment ataupun asset, and also to protect the natural environment. So kalau adik-adik pernah tengok macam deep water horizon, itu antara the major incident in oil and gas industry nowadays. which is drilling during the hydrocarbon drilling. There is a incident that happened in the rig. So in that video, if you ataupun in that movie, if you can see, they using the submersible type of rig, bukan jackup rig. So the submersible, dia floating. Sebab apa dia pakai submersible? Sebab the water depth limitation. So macam kita di Malaysia, water depth kita hanyalah sekitar 70 ke 100 meter water depth. Tapi kalau macam contoh movie Deep Water Horizon tu, it is in North Sea. So it is a deep water punya area which is ranging around 500 to 2,000 meter water depth. So that's why they are using that kind of rig which is submersible. So submersible ni dipakai anchor untuk dia secure the position. Okay. So that is number one, which is to minimize the risk. So with this geophysical and geotechnical survey, we can certain the uncertainties of the seabed condition. Kemudian this process juga untuk identify all the possible constraint and hazard, including man-made. Man-made ni contoh kalau ada the facilities ataupun apa-apa yang structure buatan manusia, especially we known as a brownfield, juga natural hazard which is known as geohazard, and also geological features which may affect the operational ataupun environmental integrity of the proposed drilling operation. Okay. So sometimes kalau tengok in term of geological ataupun geohazard dekat site ni kita boleh mitigate. So macam again saya bagi contoh Deep Water Horizon juga, one of the dia punya root cause adalah dia punya drilling dekat dengan shallow gas punya area. So maybe it's to certain degree it's penetrate the shallow gas area. So that's why the gas ataupun the gas is pop up and release suddenly. Okay. Kemudian to allow appropriate operational practice, okay, to be put in place to mitigation any risk that has been identified. Kemudian with this survey, kita akan dapat plan the mitigation ataupun macam mana kita nak control that kind of hazard which is may potentially risk to our operation. So we can properly control ataupun put the mitigation barrier in order to allow the operation to be conducted safely. Kemudian to provide sufficient data to fully assess a potential top hole drilling hazard at this location. Macam saya mention before, antaranya adalah geohazard punya potential that may harm to the drilling operational. Contohnya shallow hazard ataupun seabed, shallow seabed zone which is may harm to the jackup rig leg during dia punya jacking up punya proses. Okay, this is the potential geohazard and seabed features hazard. Okay, so hazard ni apa kan sebenarnya? Saya sebut hazard. So hazard ni adalah dia adalah bahaya yang menunggu kita. So kalau kita silap dia ada kesilapan dia, it may pose a risk. So risk ni kalau dari segi definition pula adalah hazard time consequence. Consequence ni adalah kalau berlaku sesuatu kejadian, apa dia punya impact dia ataupun significant impact dia kepada sesuatu facility tu. So hazard time consequence it become a risk. Okay. So we need to take care dulu this hazard ni dulu in order to manage the risk. So kalau kita dah tahu, kita dah boleh identify apa potential hazard, so insyaAllah consequence tu takkan wujud ataupun may reduce dan kita boleh reduce the risk level. Okay. Okay, antara potential geohazard sebelah kiri ni saya listkan the potential geohazard ataupun daripada natural punya semula jadi. Okay. Which is a buried channel, a scour, coral, punch ni adalah mungkin we can say it's a consequence lah. Shallow gas, kemudian in term of hazard ataupun man-made punya hazard adalah presence of existing pipeline, insufficient leg length, presence of footprint ataupun crater. Crater ni adalah dia jadi macam lubang besar dekat seabed. Okay, dia ada satu lubang besar. Footprint ni adalah bekas tapak kaki Geocamp. So itu pun may pose a hazard to Geocamp punya entry. Mungkin area tu adalah brownfield, which is sebelum ni ada Geocamp yang dah masuk dekat area tu. So ada kesan tapak footprint daripada Geocamp tu, which is ataupun secara engineeringnya kita boleh cakap the area has been disturbed lah, ataupun the stability of the soil at that area has been disturbed. Okay. Kemudian presence of existing fire platform. So ini pun hazard to the operation juga, present existing fire platform. Kat Malaysia ni mungkin saya tengok tak banyak lah di existing ataupun abandoned fire platform dekat Malaysia. Tapi di Indonesia agak banyak sebab tak tahulah, mungkin area yang saya pernah pergi tu macam Javasi, area itu adalah prone kepada subsidence punya isu ataupun subsidence ni adalah satu fenomena geological punya fenomena yang mana dia punya the soil ataupun the global soil tu dia settle ataupun going down. So bila going down tu the platform tu will sink lah ataupun sunk, dia tenggelam. So that's why that the most of platform at that area tu in Javasi tu they need to abandon because of the subsidence punya issue. Okay. So all of these hazard ataupun geohazard which impact ataupun may impact to offshore facilities ni will again kalau kita translate to money, it will make a million ataupun billion of money, okay, in term of cost. So it is a very significant impact lah to the operators macam Petronas ni. And that's why we are very particular on this survey ataupun geophysical dan juga geotechnical survey ni, in order to certain the potential hazard that may impact to the operation of the Geocamp especially dan juga platform installation. Okay, a bit not too detail tapi just again a brief jugalah on what is a geophysical survey. So the geophysical survey is actually a detailed geophysical of the seabed, seabed dan juga subseabed. Subseabed ini di bawah permukaan laut tu, di bawah permukaan seabed. That help in managing the risk assessment ataupun to perform the risk assessment and cost-effective design of marine structure installation dan juga kita panggil value engineering ataupun value creation ataupun cost saving bila kita nak buat ataupun kita nak go for design for this marine structure. So three main type of geophysical survey that typically we are conduct, which is first adalah a single dan juga with combination of multi-beam echo sounder punya survey. Which is this survey ataupun this survey is to establish the seabed bathymetry and topography. So the result daripada multi-beam echo sounder tadi dia akan keluar macam ni in 3D. So kita akan view ataupun geophysicist ataupun surveyor dia akan view ataupun plot the data tu, which is data acquisition from this multi-beam echo sounder punya survey dalam bentuk 3D dalam geospatial punya platform. Normally they are using ArcGIS lah. So they will plot like this. So kita boleh view the seabed punya condition dalam bentuk 3D. And then the next also, this is for your information, it is a single path ataupun ataupun kita buat ni sekali harum. Bila kita mock ataupun kita buat geophysical survey ni, kita buat sekali. Maksudnya dalam atas kapal tu akan ada single beam, ada multi beam, ada side scan sonar dan juga ada SBP ataupun sub bottom profiler. And sometimes kita juga ada ataupun carry di high resolution seismic refraction ataupun 2D seismic. So kita kalau biasa tengok video atau apa, ada kapal tow satu jenis of cable, contohnya lebih berukuran dalam 4 inci, 5 inci dia punya diameter. So they will tow around mungkin 1 kilometer on the on the after deck punya tu, belakang kapal tu. That was they call it extreme lah. Okay, sorry. Back to the side scan sonar ni, they will produce the sea floor morphology and reflectivity and identify seabed feature. So side scan sonar ni dia macam kamera 2D kamera yang boleh ambil gambar secara jelas, gambar di permukaan dasar laut. Okay. So contoh dia data macam beginilah. Ni example side scan sonar data for ni adalah shipwreck ataupun submarine, saya rasa submarine wreck that has been captured via side scan sonar. So and then the sub bottom profiling, which is investigating sub-seabed geological profile in shallow depth. So shallow ni we are talking about 100 to 200 meter from the seabed. Ni kita panggil seabed ataupun sea floor. So sub bottom profiling ni dia akan measure daripada seabed ni ke bawah. So about shallow dalam 100 meter ataupun paling dalam pun 200 meter lah. So it is more ataupun dia punya in term of resolution tu kita nak tengok lebih kepada shallow lah ataupun di dasar di bawah seabed ni yang masih cetek lah, around kita interest 500, 700. Kemudian if you want to go deeper, deep into the sea floor punya cross section, kita akan menggunakan this high resolution seismic refraction ataupun seismic refraction instrumentation designed for investigating the sub-seabed geological profiler, which is deeper. So dia punya data lebih kurang sama, tapi it's go more deeper, mungkin sampai to certain degree sampai 1,000 meter. So kita boleh tengok the profile of the soil beneath the seabed lah. So ini antara contoh sub bottom profiler punya data lah. So daripada sini geophysical akan pass this all this data ni kepada geotechnical engineer untuk geotechnical tengok in term of ataupun to correlate between this geophysical punya data dan juga geotechnical punya data nanti. So this report ataupun report juga geophysical dia akan share to the Geocamp punya owner, which is they will analyse juga the situation ataupun the result from this geophysical survey. So everybody okay ke? Atau heavy sangat?
Okay, Encik.
Okay. Hari ni sebelum ni saya rasa masa yang diberikan 1 jam, tapi this time Dr. Nazirah bagi kat saya 2 jam. So tu mungkin saya banyak sikit melelong ke tu, panjang sikit cerita.
Okay, tak apa.
Tak apa, betul, boleh.
Boleh je.
Boleh. Okay. Thank you. Okay, so I want to touch a bit on the new technology of this geophysical survey, which is on the autonomous underwater vehicle, ataupun we known as AUV lah. So dalam EUV ni ataupun orang panggil mini submarine pun ada juga, unmanned submarine. So kalau adik-adik pernah tengok, kalau dulu mungkin pernah tengok berita kan, during SNR ataupun search and rescue for kita punya MH370 kan. So they are using this AUV untuk explore ataupun untuk search the position of the aircraft. So tapi itulah sebab yalah laut ni terlalu luas so agak tough untuk kita faham sebelum. So normally kita akan narrow down ataupun kita akan identify mana lokasi yang kita nak survey dulu, so supaya survey tu objektif tu untuk kita easy to get lah. Tapi kalau tak ada uncertainties tu banyak, tak tahu dekat mana position, so agak-agak sukar. Tapi again, the data tu masih lagi sama lah. Via this AUV, it will provide the side scan sonar punya data. So kalau tengok ni mata kat tepi dia ada starboard and port side, which is kiri dan kanan dia ada this side scan sonar. So beneath the AUV ni juga we install the sub bottom profiler, mini sub bottom profiler, and then we also have the multi beam echo sounder dan juga altitude meter, echo sounder, single echo sounder, forward looking sonar kat depan ni untuk avoid any collision. Sebab dia normally dekat dasar laut ni we are using this kind of technology ataupun AUV ni for the deep water punya exploration, so dekat laut dalam. So saya pernah experience untuk operate this AUV at about 1,000 to 2,000 meter water depth lah in Andaman Sea dan juga in South China Sea. Kemudian so dia punya purpose sama juga macam all those geophysical survey, which is to conduct the hydrographic survey, SNR, search and rescue, pipeline inspection juga they can perform. Marine geohazard survey that I was briefed before, and then pre-engineering and pre-lay survey. Ini selepas construction of the pipeline tu dia boleh dive and survey balik the position of the pipeline that has been buried. Okay, via this technology is able to produce a high resolution data in shorter time. So compared to the I can call it a conventional geophysical survey method, this by using this AUV we can have a more better resolution in terms of resolution. Kenapa? Sebab satu, kalau kita dealing with the deep water atau ultra deep water punya condition, we can dive ataupun we can fly this AUV close to our seabed. So normally it's ranging around 50 meter to 100 meter, depend on the seabed punya terrain. Kalau it is a bit risky, kita akan fly it a bit higher, walaupun on top of it we have forward looking sonar on at front ataupun at the bow of this vehicle, which is allow vehicle to avoid any collision. Maksudnya dia boleh seri untuk berpusing and avoid daripada hit any structure ataupun any terrain, steep terrain in the sea. Okay, so because of dia punya nature can dive close to the seabed, that's why it's able to catch a better resolution in terms of data lah. So compare kalau for deep water, sebelum ni juga the industry is using deep tow punya conventional geophysical method, tapi again bila deep tow tu again dia punya altitude ataupun ketinggian daripada seabed tu agak limited ataupun agak tinggi, especially in ultra depth punya condition, resulting huge cost saving to the industry, of course, compared to the conventional geophysical method. Ini we talking about mungkin untuk shallow water depth mungkin not significant ataupun mungkin still conventional method still lagi cheaper. Tapi kalau deep water atau ultra deep, again using this AUV, we can save a lot of money because the mother vessel just need, if we operate in fully autonomous punya mode, we can save millions of dollars lah for the fuel for the mother vessel. So mother vessel just need to static ataupun they just consume very minor ataupun very minimum in term of fuel consumption bila kita fly this AUV in autonomous mode. So dia jalan sendiri. And then she is a self-propelled unmanned water vehicle that is remotely control ataupun pre-programmed. So we have three types of operation mode, which is supervised. So supervised ni kalau dalam keadaan yang agak risky, contohnya very dangerous ataupun very challenging terrain. So kita occupy in supervised mode ataupun in area yang kita familiar, especially in green field area. So kita akan supervise. Supervise ni maksudnya kita still monitor. Dalam screen kita masih ada lagi the about to real time punya update daripada vehicle to the mother vessel ataupun to the operator on board the mother vessel. So we still can supervise, meaning kalau kita nak tukar dia punya heading, tukar dia punya line of way, we can do it via a supervised punya mode. And then the most optimal punya operation is semi-autonomous lah. So we can semi supervised dan juga semi-autonomous. So kalau kita tengok kita nak ubah haluan ataupun the direction of this vehicle, we can do, and to certain degree we can let it fly via itself by pre-identifying ataupun pre-identifying the waypoint. So kita dah siapkan the waypoint tu ataupun survey line tu siap-siap. So dia akan just follow je. Mungkin nowadays mungkin adik-adik mungkin biasa dengan drone. So drone pun dah ada that kind of capability for semi-auto ataupun autonomous, which is using the same concept what we are using in this mini submarine ataupun AU. And then like I mentioned before, the autonomous mode, which is it is a fully autonomous, we just let it fly. Tapi still on the screen tu operator still lagi boleh monitor via dia punya trajectory ataupun prediction of movement of this vehicle on the screen. Maksudnya based on prediction, kita still lagi boleh monitor because of the speed, current, sea current semua kita boleh measure kan. So kita tahu, kita boleh predict okay kat mana dia berada sekarang. Okay, so untuk launch and recovery, untuk deployment, they just lower down this launch and recovery punya system to the sea, and then kita lepaskan dia punya like a rope yang entangle ataupun tie to this vehicle, and we let it dive to the water. And then for the recovery, certain manufacturer tu different recovery punya plan. Macam myself, sebelum ni pernah operate this Geocamp, which is manufactured by Kongsberg, Norway. Dia punya recovery system is via a grappling tool, ataupun kita ada satu pressure macam senapang yang kita tembak ke arah vehicle, tapi sebelum tu bila dia surface to the water tu, dia akan pop up dia punya nose, and dia akan keluar messenger line, kita panggil messenger line. So bila ada messenger line tu, kita akan target pinpoint to that messenger line untuk kita grab ataupun kita tembak untuk tangkap this Yugi. Yugi ni basically bahasa Norway. So kalau tak silap dia punya maksud ni adalah dolphin, kalau tak silap lah. Dah lupa. Okay. So habis bab geophysical, so I will go down a bit on the offshore soil investigation ataupun geotechnical investigation lah. Geotechnical. So this geotechnical investigation program is designed to acquire reliable information on the stratigraphy, geological characteristics, and properties of different soils and rocks on site. Okay. So maksudnya kita deploy this vessel, geotechnical vessel, soil boring vessel untuk dapatkan soil sampling mainly. So on top of soil sampling tu kita ada method juga. So contohnya geotechnical data acquisition comprises of combination of the technique, coring ataupun sampling that I mentioned before via seabed and drilling mode for soil identification, description and subsequent offshore laboratory testing where geotechnical engineering parameters are determined. So gambar kat tengah ni adalah the situation, the condition of the offshore lab on board. So kalau dekat kapal ni, ni kedudukan lab kita. So ni adalah drill rig. So bila dah sample dah they bring from the seabed, so dia akan take out and bring to the lab. So dia punya sampel punya bentuk macam ni, dia panjang macam lemang. Kita dekat offshore panggil dia lemang. Okay, ini sampel ni dia cantik sebab mainly dekat semenanjung Malaysia lah, which is Peninsula Malaysia. Kalau Sabah Sarawak dia ada interbedded with sandy punya soil. So dia tak solid macam this type of soil, but it is a clay. We can say it is purely clay. Kalau kita dekat semenanjung, especially in offshore Terengganu lah. Okay. So in this laboratory we will conduct first, bila sampel sampai tu kita akan extrude, kita akan keluarkan dia daripada kita panggil UD tube ataupun satu tube stainless steel tube yang kita gunakan untuk kita bila kita cocok ataupun kita drill and then kita penetrate to the ground using this UD tube, and then kita take out and bring to the soil to the lab, and then kita extrude, kita tolak, kita push out the soil ni without disturbing dia punya soil punya condition. Tapi sometimes kalau kita dealing with very soft punya clay ataupun soft clay, sometimes firm juga, we need to be more hati-hati, kena more careful because the soil is very sensitive. Bila sensitif ni, bila kita do a testing, especially strength test, contohnya kalau kita buat Trovin ataupun pocket penetrometer, and dia punya result dia kurang reliable sebab soil tu dah been compressed ataupun decompressed. So that's why kalau bila kita extrude tu, we need to be more extra careful, especially for the very soft punya soil punya condition. So bila kita dah extrude tu, kita akan ambil gambar sampel ni, kita akan labelkan dia, kemudian take for the kita akan timbang berat dia, kita akan some portion kita akan drykan dia untuk kita get dia punya density. Kemudian some portion we testing for pocket penetrometer dan juga Trovin untuk tahu dia punya shear strength. And then the best sample kita akan do for UU test ataupun unsaturated undrained punya testing on board dalam kapal. Kemudian sebahagian lagi kita akan transport ke onshore lab untuk buat further lab testing dekat darat. So kita ada offshore lab dan juga onshore lab lah. Okay. In situ testing for soil stratigraphy and determine of geotechnical engineering parameters via CPTU ataupun shear vein. So ni adalah CPT punya cone. On top of sampling, tadi saya explain pasal sampling, kita ada juga in situ test which is via CPT. CPT ni kita cocok, kita terus dapat dia punya graph ataupun result, mainly on the dia bagi shear strength of the soil lah, shear strength, dia bagi pore pressure, friction. So daripada data-data tu kita akan interpret, geotechnical engineer on board dia akan interpret apa type, what kind of data ataupun soil beneath the seabed, apa type of soil. Okay, these are the keadaan dalam drilling cabin, soil geotechnical drilling cabin. So ini juga keadaan di drilling floor, geotechnical drilling floor. So mungkin adik-adik kalau tengok mungkin tak dapat bezakan keadaan drilling floor untuk geotechnical ni dengan drilling floor for the hydrocarbon punya drilling. Itu almost lebih kurang. Mungkin geotechnical ni mungkin bit more kurang canggih lah compare to hydrocarbon, lagi canggih daripada drilling floor. So because we drill for the shallow, biasanya shallow for the soil sampling, but hydrocarbon is drilling for the hydrocarbon gas ataupun oil. In term of dia punya device ataupun sistem, in geotechnical industry kita ada juga a safety system, contohnya blowout preventer system that we install to avoid any incident, mainly bila kita hit the shallow gas hazard. So myself juga dah experience a few shallow gas punya blowout ataupun incident in offshore. So it is agak tough juga lah to dealing with that kind of situation. So sometimes it's very interesting and sometimes very challenging. But challenging tu bila kita fikir balik ataupun kita ingat balik, it is very interested lah. Because we are able to have that experience. So this is the photo that shows the borehole log that we produce for offshore. So onshore pun sama, lebih kurang gini lah dia punya borehole log. So ni untuk offshore. Okay. So but before we start the geotechnical drilling activities tu, kita kena deploy the anchor. So sebelum kita deploy the anchor tu, sebelum kita mobilize ataupun sailing out, kita kena as a geotechnical engineer ataupun party chief lah. Party chief ni adalah the project manager on board. We call it, kalau dia punya term dekat offshore tu, we call it as a party chief. So a project manager on board to ensure the anchor pattern is in order, especially that area that we are dealing with brownfield punya area. Adanya kita kena crossing a pipeline, a live pipeline, which is may pose a hazard and then risk to the pipeline dan juga kepada kita punya vessel. So the purpose of this anchor pattern is to identify a safe place for anchor deployment and then to find a suitable vessel heading based on the weather condition, contohnya wind, swell and current. Because these three punya sea punya condition ni sangat penting lah, especially bila kita operating in monsoon punya time, whereby we cannot predict ataupun unpredictable punya weather condition. Sometimes the wind and swell ataupun current jarang juga, wind and swell lah, biasanya akan berubah. So sometimes it come from the east, kadang-kadang dia datang daripada timur barat, so unpredictable. So we need to be make sure kita punya pemilihan heading dan juga kita punya vessel position tu, it is based on the data that we have from the meteorological punya department. Okay. Kemudian we are using the hydrographic data acquisition, navigation and processing software to plot this anchor pattern on board. Contohnya kita biasa pakai, kalau zaman saya dulu biasa pakai Kinsey. This is ataupun dia punya software name Kinsey ataupun Stafix. So this punya view adalah using the Kinsey version 7.5 lah. Okay, we plot this on board. So kita akan tahu kalau kita punya vessel ni drag due to the strong wind ataupun strong current ataupun high swell, so we can monitor from this. So captain on board pun dia akan tengok screen yang sama, particip pun akan tengok screen yang sama untuk monitor. Driller pun tengok screen yang sama. So this will be monitored by a dedicated surveyor on board lah. Surveyor on board for this geotechnical campaign. So dia akan plotkan, dia akan bagi tahulah, updates lah to the key personnel on board. Sometimes we are using TMS ataupun TAC ataupun BMS, barge management system, TMS, BMS, when deployment assist by anchor handling TAC, ataupun bila kita macam contoh ni saya bagi, bila kita nak crossing the pipeline, kita nak deploy anchor kita, which is need to cross the pipeline. So we need to use, sometimes we use AST lah ataupun anchor handling TAC untuk avoid ataupun one of the mitigation punya plan lah. Okay, itu antara kita punya plan untuk make sure the risk is low bila kita conduct this operation. So sometimes the position of this anchor may very close to the pipe, so we need to using that ESP, and sometimes very far, then we can decide not to use that ESP. So it will be cost benefit to us lah. Okay. Okay, that's for anchor pattern. Just to give an overview, the condition ataupun how kita punya drilling vessel atau geotechnical vessel looks like. So these are the drilling ataupun geotechnical drilling spread. On board kita ada derrick, kita ada power swivel, sama macam hydrocarbon jackup rig punya facility. We have a drill pipe to drill up to the seabed and below the seabed, sub-seabed. Kalau tengok sini ada anchor. Kalau sini dia note sebagai soft mooring. Soft mooring bermakna kita tie to offshore punya facilities. Contohnya platform. So kita gunakan soft mooring, kita guna tali. Instead of kalau anchor wire ni kita menggunakan saya tak ingat apa material tapi it is metal lah, metal part of anchor wire. Ini vessel ni dia mungkin dia buat the operation tu close to the kita punya platform. So dia mock sekali di ROV and the containers of ROV lah, remote operating vehicle, ROV untuk buat inspection dekat platform. But normally kita tak bawa lah ROV ni, tak perlu pun. So kita hanya bawa rig, kita ada lab punya container, dalam tu ada all the consumable punya tools and material untuk kita pakai masa kita buat di geotechnical operation. Okay. So now kita akan go to the geomatics punya subject lah. So what is accuracy and precision? Kalau adik-adik boleh Google, so accuracy ni adalah it is a closeness of the measurement to a specific value. So while precision ni is the closeness of the measurement to each other. Okay. So saya bagi contoh yang ni lah. Kalau bila kita bidikan kita on the center tu kita panggil high precision juga high accuracy. Okay, ini yang terbaik lah kalau kita cakap high accuracy and precision ni itu yang kita nak. Tapi sometimes kita ada juga the condition bila kita dapat accuracy tu is very low. Accuracy low maksudnya dia tak kena target kita. Target kita kat sini tapi dia away. Tapi dia punya data tu it is scattered closely to each other. Still lagi high precision. Tapi accuracy tak ada. So it is off from the accuracy. So ini contoh untuk high accuracy tapi low precision. Precision ni bila dia scattered the data tu sangat scattered. So dia tak narrow to ataupun focus to one single point. So this condition is very low accuracy and juga very low precision. And in order to achieve both accuracy and precision during the geohazard site investigation campaign, positioning water depth measurement is the main crucial geometric activity to be part of the scope. So benda ni adalah benda yang basic, yang compulsory untuk setiap survey, especially geophysical dan juga geotechnical, dan bukan juga these two survey, installation of the platform, rig move ataupun rig punya jackup punya entry, semua tu memerlukan high accuracy dan high precision, especially bila kita dealing again dalam area yang brownfield yang dah been occupied ataupun dah has been developed, sebab kita dah macam fix the position tu, yang intended position tu dah been macam kita dah tak boleh lari dah. Memang that is only the area yang kita kena work. So kita tak boleh offset, kita tak boleh off daripada the intended location tu. So that's why kita perlukan teknologi ataupun the instrument yang akan give us the high accuracy dan high precision untuk kita make sure kita punya campaign tu is meet the objective lah. Okay. And then again saya nak explain in term of dalam survey ni dia ada satu term we call it sebagai coordinate reference system ataupun CRS, coordinate reference system. So biasanya kalau dekat Malaysia ni known as timbalai ataupun kertau, GDM 2000, WGS 84. Dekat Petronas ni kita dah standardize untuk pakai satu saja system which is WGS 84. Kita pakai standard. Kalau sebelum ni kita ada kertau, kita ada timbalai. So now kita pakai satu saja datum which is WGS 84. So a geodetic datum ataupun reference ni actually it is a frame an abstract coordinate system with a reference surface. Contohnya sea level that serve to provide known location to begin survey and create map. Okay. Kemudian what is projection? Apa itu projection? So kita ada datum, kita ada projection. So projection tu kalau definition dia adalah a series of transformation which convert the location of point on a curved surface. Okay, the reference surface or datum to location on flat plane. So kita project to the flat plane. So kita tahu kan bumi ni bulat. So daripada koordinat asal ataupun datum tadi kita convert atau kita project kepada flat punya plane on paper flat. Okay. Normally kalau dekat Malaysia ni again familiar dengan Universal Transverse Mercator UTM, Borneo Rectified Skew Automorphic BRSO. Kemudian next is what is geographic coordinate? So geographic coordinate ni biasanya it's stated dalam latitude dengan longitude lah. Okay. Kalau kita tengok, kalau adik-adik nak tengok the map, kalau dia stated dalam longitude and latitude tu, it is dalam geographic punya coordinate. Kalau dia stated dalam east northing, it is has been projected coordinate. Kita dah convert ataupun project the coordinate. Okay. So ni contoh geographic coordinate which is leg long. Oh sorry. So this one is projected coordinate. So ini dalam eastern northing. So ini kita senang nak kira. Kita pakai teorem Pythagoras. Kita dapat the distance to each point. Okay, next is the positioning system. So every equipment, especially survey equipment that we mobilize ataupun deploy in the vessel ataupun ship, we need to calibrate, especially the gyrometer. Ni gyro. Gyro ni kita nak tahu heading, the real heading, point to north, real north, and verify the GPS at jetty ataupun wharf. So sebelum kita sail out tu kita akan buat calibration for gyro. Kita make sure dia point tu betul-betul to north, then kita set sebagai dia 0, and then verification, kita verify kita punya GPS system. Dalam offshore ni kita pakai DGPS, differential global positioning system. Kenapa DGPS? Sebab it is give us more accurate and precise punya data lah. So kalau GPS tu, kalau adik-adik ada jam GPS tu, kita hanya depending on single punya satellite. Tapi kalau di GPS, kita depending on a few satellite dalam kita punya area tu. At least 3 ataupun more than that lah. Sometimes more than that. So we can differentiate ataupun kita boleh have a very accurate punya position lah. So kalau GPS tu sometimes memang dia offset tu agak wide. To certain degree sampai kalau dekat darat ni mungkinlah boleh lari sampai 10 meter, tapi dekat offshore mungkin dia off sometimes sampai 50 meter kalau tak accurate lah, kalau tak enough ataupun sufficient satellite signal pada masa certain time. So we need to ensure, surveyor on board need to ensure the satellite signal is well during the operation lah, and to make sure the data is accurate and precise. So we are using the positioning system using global navigation system via the GPS system. Contohnya very force ultra. So this is based on the US punya technology lah, global navigation system. So that is a typical that we are used for offshore Malaysia. All coordinates were located based on the CRS tadi ataupun coordinate reference system. Sebelum kita mobilize surveyor kena make sure the CRS tu betul, has been projected, data tu betul. Kalau tak nanti pergi target line location, pergi line location, which is especially kalau greenfield tu sangatlah biasa kita dengar insiden macam itu. Silap location kan, sebabnya the data CRS tu salah position ataupun coordinate at first tu salah, kita tersilap location. Sebab kalau brownfield kita boleh macam reference to the existing structure. Okay, ada platform A contohnya sebelah kiri. So bila kita tengok dekat kita punya drawing, betul ada platform sebelah kiri. So kita boleh cross reference. Tapi kalau greenfield semua sama. 360 tu luas lautan luas saja kan. Kita tak tahu mana ujung pangkal, kecuali kita ada the right navigation system which is gyro dan juga the GPS dan juga the right coordinate reference system. The positioning of the proposed location achieved using real-time GPS with a minimum 4 satellite giving a 3 fixed dimensional fix. So macam saya cakap tadi lah. So dia kena ada 4 minimum satellite untuk give a highly accurate dan juga precise in term of position. Okay. Kemudian water depth measurement. So on board ataupun on board the vessel, also the water depth also very crucial. Kita nak tahu berapa dalam. So macam the technical vessel, kita nak tahu berapa dalam untuk kita ensure kita punya cross ref or location yang kita pergi tu betul. Okay, dalam drawing contoh 100 meter water depth, bila kita measure based on echo sounder on board ataupun water measurement depth, okay betul, lebih kurang. So bagi indikatif punya reference. To ensure drill string count prior to taking seabed ataupun geophysical survey. So kita nak make sure kita punya seabed punya ataupun kita punya drill string, drill pipe tu been counted betul-betul. Dan juga geophysical survey, bila kita bila kita buat data acquisition ataupun buat the survey tu, kita kena make sure dia punya offset ataupun dia punya altitude tu adalah betul, untuk sebab nanti bila data tu dia ada geophysical kena tahu the depth, the altitude ataupun the between the sensor dan juga seabed. Calibrate at jetty using the budget method. So benda ni pun kita kena calibrate dekat jetty sebelum kita sail out. The reading were then corrected with tide prediction to yield ataupun MSL. Biasa kita pakai mean sea level. Okay. The tide prediction was based on nearest offshore facilities, contohnya platform. So kita akan dapatkan the tide prediction, pasang suhu air. There is a crucial juga, especially bila kita buat the technical punya campaign ataupun soil boring. Again, pasal drill string kita tadi lah, kalau masa high tide, kita punya numbers of pipe tu mungkin increasing, lagi banyak pipe kita required because of the water level ataupun the level of water tu dia makin dalam lah. Okay. Once the vessel is anchored on location, initial water depth measurement was taken using the ship calibrated echo sounder, contohnya Ogos echo track, dan juga untuk survey ataupun geophysical ataupun geotechnical kita ada our own echo sounder juga ataupun water depth measurement. So kita punya echo sounder which is memang hull mounted ataupun dah di-install dekat kapal tu permanently dekat hal kapal tu. So tapi kalau macam untuk survey, kita ada attach kita punya survey pole ataupun tiang yang kita akan lower down bila kita dah sampai ke location untuk kita measure this water depth. So this is to measure water depth again, kita pakai single echo sounder. Tadi saya mention tadi masa kita buat geophysical survey, ada juga single echo sounder dan juga multi beam echo sounder. So dua-dua adalah type of echo sounder, tapi yang multi beam tu dia boleh bagi multi layer of data sehingga kan kita boleh plot in 3D punya view. Okay, so this is the most important punya slide, which is the incident that due to underestimation of the field geomatics ni. So kalau kita ataupun as a geotechnical engineer on board, kalau kita ataupun civil engineer, structure engineer, kalau kita underestimate this kind of hazard ni, it can pose us incident lah, which is incident to the facilities, to the Geocamp, even to the platform yang has been installed pun. Okay. Dan juga sometimes kepada geotechnical survey vessel ataupun geotechnical soil boring vessel. Okay. Why? Because perform offshore site investigation at not intended location due to wrong coordinate. Saya dah highlight tadi. So salah location. So geometric is very important. Kalau salah location, kalau dulu masa kontraktor, of course kita Petronas tak akan bayar lah. Kalau kita suruh pergi location A, dia pergi buat location B sebabkan dia punya kesilapan, silap koordinat, silap location. Okay. Kemudian Geocamp spark can damage due to seabed debris ataupun adanya substructure yang kita tak tahu sebab kita tak perform the geophysical survey sebelum tu, ataupun a low quality of data from the geophysical survey. We cannot interpret ataupun geophysicist tak boleh interpret adanya seabed features ataupun seabed debris dekat seabed tu. So it may damage to spark can Geocamp ataupun kaki spark can. Geocamp leg broken and tilted towards live platform due to the entering existing footprint. So it is kalau condition punch through ataupun rapid leg penetration due to underestimate ataupun interpretation yang salah daripada geophysicist dan juga geotechnical engineer may pose to this kind of consequence, Geocamp leg broken. So nak pula dia conduct dekat field brownfield punya area, very close to the platform because dia punya drilling slot ni dekat platform ni, that existing drilling slot ni dekat platform. So dia kena slot in the same slot yang dekat ada existing platform. So very close. So the gap tu mungkin a few meters saja. So kalau the condition of the seabed is not stable, is wrongly interpreted by the engineers atau the physical. So kalau terjadi apa-apa, it may topple ataupun hit the existing live platform. So, platform yang live tengah operate. So may cause a fire lah. Lepas ni saya share juga the real cases recently happen dekat Malaysia juga. Kemudian Geocamp hit a shallow gas resultant blowout event due to misinterpretation of geophysical data. So ini macam case itulah apa tu deep water horizon tadi sebagai contoh. And other juga ada punya exploration punya itulah incident due to shallow gas punya event. So because of misinterpretation daripada geophysical data. Okay, dia tak perasan ada gas, kita panggil gas pocket. So gas pocket at certain depth, very shallow. So kita tak ready ataupun driller tak ready, tak well prepared. So bila kita hit tu, kita tak sempat nak control. Tapi most of the Geocamp, the modern punya Geocamp now, it is automatic BOP can trigger to close the valve already. So tapi to certain degree mungkin the pressure is cannot contain by the design punya BOP. Kemudian pipeline riser unable to connect due to misalignment between pipeline and platform. So bila dah nak time nak connect tu between pipeline dan juga platform tak match. Sebabnya silap coordinate. So this kind of consequence may happen in offshore lah. Kemudian anchor drag and snap the pipeline on the seabed. So anchor may drag during the bad weather due to squall. So I was experienced juga before when my vessel is dragged, the anchor of that vessel is dragged, and luckily it's not snap the pipeline lah. It's not snap. It's just bila kita secure balik that anchor is bila kita plot balik, it's just less than 10 meter daripada pipeline, live pipeline, which is sebelum tu around 150 meter. Due to squall ni macam meribut dengan laut kan, which is dia punya wind punya speed more than 50 knot. So the vessel is cannot sustain, ataupun the anchor, anchor mooring tu cannot sustain from the squall ni. So it's drag the anchor lah. So that kind of. So recently we I think mungkin sebahagian daripada kita aware the latest incident that offshore driller sends notice of abandonment to sunken rig. This is what happened dekat kalau tak silap di for Naga 7, so which is dekat area Sarawak. So that Naga 7 is owned by Velesto. So that operation is for ConocoPhillips. So bukan untuk Petronas lah. Luckily bukan they do the operation bukan untuk Petronas punya block. It is for ConocoPhillips lah. So the incident happened on 3rd May, which is one of the rig legs penetrated into soil formation while jacking up at Salam 3 well of the coast of Sarawak for ConocoPhillips. So the rig tilted as it subsequently on 4 May, it is totally sunk ataupun dia tenggelam, totally tenggelam. So all the personnel on board need to evacuate and selamatkan diri lah. So it has been rescued by the nearest vessel juga, ataupun biasanya dalam operation rig ni dia akan ada standby vessel untuk evacuate ataupun untuk for evacuation purposes. So this is the recent incident dekat Malaysia. So as a conclusion, by understanding of the field geometric fundamentals, it is a must for an offshore civil engineer lah. It's very crucial and important. Basic tu kena ada walaupun mungkin tak detail, sebab the detail technical part tu will be the role to will be carried by a surveyor on board, which is a geometrics punya personnel on board lah. Kemudian survey accuracy and precision is a main element to be achieved in offshore industry. Macam saya katakan sebelum ni, sangat-sangat penting this element. Accuracy and precision. Kalau tak silap location, then kita akan face hard time lah in future ataupun after that campaign. Underestimation of positioning and water depth measurement for site investigation and other offshore activities will lead to a catastrophic incident, which is a resultant loss of $1 million. Macam contoh tadi, jackup dah tombang, dah tenggelam, so totally lost. Even that jackup tu, kalau sebelum ni untuk rent that jackup tu, it is may cost around 500 to $1 million a day. So you can imagine kalau dia dah totally lost tu berapa million, the jackup owner dah lost. So that kind of catastrophic incident tu we need to lesson learn and avoid lah in future. So with that, I thank my presentation. I end my presentation for today. Thank you very much for your patience. Back to you, Dr. Nazira ataupun Miss MC.
Okay, thank you very much, Encik Shazwan. Thank you so much for the informative sharing. Untuk pengetahuan Cik, ramai gila yang dekat YouTube live yang bagi tahu diorang memang minat bidang ni, bidang offshore ni. So banyak jugalah soalan daripada mereka. So salah satunya adalah apa requirement ataupun course yang patut kami ambil untuk ke bidang offshore ni?
Okay, thank you Miss No Aiza, the MC today. Requirement untuk menghala ke arah bidang ni. Basically, saya pun macam you all dulu kan. Back in 2005, saya masuk university in 2000 on my time tu we required to complete 5 years. Mungkin sekarang dah 4 tahun untuk engineering. Tapi from SPM lah, I straight away masuk UTM for 5 years under civil engineering punya course lah. So basically tak ada specific course pun untuk kita jump to this industry. Tapi kita as a civil engineer, we can kita punya opportunity tu agak besar sebenarnya, sebab dalam kita punya minor subject juga kita ada touch for the, I'm not sure, dulu saya ada ambil elective lah, tapi itu bukan kredit untuk saya involved in this industry, which is for the marine punya structure punya subject. Tapi that was not the credit that I carry untuk apply for that position pun back in 2008. Sebab sebelum tu macam saya cerita tadi, that first 3 years I was involved in construction, chemical ataupun petrochemical plant punya construction. So saya just try. So alhamdulillah, my rezeki on that time, I was given the offer untuk join this the company on that time lah, Offshore Works Sdn Bhd, as a geotechnical engineer. So that was my my starting career for offshore lah. So tak ada spesifik. Okay, thank you.
Oh, okay. Soalan yang lain, kalau macam kita sedia tahu, kalau bidang offshore, peluang pekerjaan untuk dalam bidang offshore ni untuk wanita sangat sedikit. Adakah mitos ataupun fakta? Ramai yang berminat ni, ramai sangat.
Mitos ataupun fakta untuk wanita. Saya boleh katakan mitos lah kot. Recently it is a mitos, tapi sebelum ni mungkin itu adalah fakta. Mungkin sebelum ni kalau kita talking about mungkin 10 years back lah. Tapi nowadays kita tengok dah ramai surveyor, geophysical ataupun civil engineer, geotechnical engineer yang dah involved in this offshore punya industry. Even for macam hydrocarbon punya drilling in jackup rig tu sendiri, ramai dah girls yang jadi driller tu mungkin kurang lah. Tapi macam engineer on board, untuk wireline punya engineer, dah ramai sangat girls yang involved. So it is bukan halangan untuk girls to be an offshore punya engineer ataupun surveyor on board nowadays. Sebab kalau dulu mungkin agak tough. Kalau even my time pun in 2008, in term of communication tu sendiri pun dah sangat-sangat tough. Maksudnya bila saya pergi sail out to offshore tu, I will disconnect with the real world dengan offshore punya world. Maksudnya tak ada communication masa tu, just a telephone, WhatsApp tak ada, internet tak ada lagi pada masa tu. Cuma we are using the satellite punya phone, kalau in case of emergency, satellite punya phone. So we cannot connect to, we cannot call our parents, we cannot call anybody on kita punya family unless kalau ada emergency saja. So that was the challenge. Mungkin pada masa tu girls agak kurang, tapi ada juga, tapi masih masa tu pun dah ada a few geotechnical engineers yang girls yang involved in this industry. Okay.
Okay, baik. So, girls out there jangan risau, boleh je apply. Okay, ada rezeki kita masuklah bidang offshore tu. And then Cik, ada yang bertanya kalau diorang ataupun student nak LI, nak latihan industri dekat platform offshore tu, macam mana prosesnya? Boleh ke kalau kita orang nak LI kat situ?
Okay, untuk LI ataupun intern nak pergi ke offshore facilities tu, yang saya tahu memang susah lah. Bukan susah sebab apa? Sebab it is involved in term of cost. Sebab to be fit to go to offshore, personnel ataupun engineers ataupun personnel who are going to offshore, we need to undergo a few medical test dan juga certification, contohnya BOSIEC ataupun emergency untuk live punya training, untuk helikopter punya live punya training. Kalau kita that kind of a limitation lah. So kalau kita nak sending the intern ataupun trainee kat offshore tu, even Petronas pun memang kita tak send lah. Satu, because of we need to send that people who want to go to the offshore to that medical check-up, full medical check-up dan juga offshore training punya center. On top of that, because of the risk lah, so we need to be trained before we are ready to go to the offshore.
Okay. Okay, next question. Ada yang bertanya mengenai gaji dan juga risiko lah kalau bekerja di offshore. Risiko individu sendiri.
In terms of risk, saya sentuh risk dulu lah. In terms of risk, it is classified sebagai high risk punya profession. Even kalau macam tu kan, biasanya kalau insurance punya personnel ataupun agent, bila dia approach to kita punya to us, especially for offshore punya personnel ni kan, sebelum tu dia tak tahu certain tu kerja offshore kan, so dia approach. So bila tapi bila dah tahu background dia punya the financial punya stability, they are interest untuk close the deal lah. Tapi at the end bila dia tanya, cik kerja apa? Kerja offshore. Oh sorry cik, insurance tak boleh cover. So that's the kind of risk. Mungkin saya tak sure, mungkin nowadays dah ada specific insurance yang boleh cover, tapi mungkin agak limited lah. Tapi basically kalau general punya insurance tu memang tak cover for offshore punya tu. So kalau nak cover pun mungkin cover pun macam saya myself, sebab saya bagi alasan reason sebab saya dah tak 100% work in offshore, so saya banyak to office base in KLCC, so mungkin that because of that reason they still accepted for insurance lah. Tapi kalau yang tu memang mungkin saya tak naklah cakap tak boleh dapat insurance dan tak boleh cover insurance, tapi agak hard untuk get that approval for insurance. As well as for salary tu of course lah, because we are dealing with hydrocarbon, with remoteness, bila kita work jauh di offshore sana, kita naik helikopter, sometimes we need to ride the crew boat, kita sail a few hours, macam saya punya time dulu sampai ada, tengok location lah, kalau jauh tu sampai 20 hours sailing kan, bangun tidur tak sampai lagi, so very far. In terms of salary of course it is a bit different lah compared to onshore punya industry. Memang ada, especially on the hardship tu kita akan being consider, most of the company will consider the hardship allowance to dia punya personnel ataupun crew. So memang akan ada different lah. macam geotechnical engineer ataupun civil engineer, structure engineer. Mungkin saya boleh katakan dia punya perbezaan tu dalam 30 to 40% daripada normal typical engineer dekat darat lah. That I can say.
Okey Encik. Okey Encik, baiklah. Soalan seterusnya, berapa lama masa kerja survey yang dijalankan di offshore? Kalau macam untuk satu projek tu, berapa lama diorang duduk dekat offshore tu untuk projek tu siap?
Okay, untuk so macam saya fokus tadi, my presentation is focus to two punya task lah, which is satu geophysical survey, nombor dua adalah geotechnical survey. Untuk geotechnical survey, normally untuk satu location, we're going to spend minimum 7 days to 2 weeks ataupun 14 hari. Itu minimum lah untuk satu location. So kalau ada satu location dia senanglah, kita pergi 2 minggu dah balik. Tapi it's not will be that case lah. Banyak case kita akan continuous akan be in offshore ataupun in the vessel. So sampaikan depend on the project. Kalau the company got a line of a project, so mungkin the numbers of stay tu dia akan jadi rotational, mungkin a month ataupun sampaikan 3 months per person, and then baru di rotate. Kalau my personal experience dulu, saya pernah task to 3 months in offshore lah. That was the longest saya pernah spend ataupun serve for offshore. So untuk geophysical survey pula lebih kurang je dengan geotechnical. Kalau satu location it may take around 2 weeks. Tapi kalau biasanya dia akan banyak location yang kita akan go to. Sebab yalah. So I think that the answer.
Okay, actually sebenarnya banyak lagi sebenarnya soalan daripada student-student ni. Semuanya memang curious sangat lah sebab memang offshore kan. Jadi tak apa, nanti insyaAllah kalau ada rezeki kami akan melawat Petronas. Boleh Dr. Nazira? Kita buat pergi Petronas.
Kalau kita dah keadaan kita dah okey, insyaAllah kita boleh pergi
kan. Jadi saya harap situasi sekarang ni lah membejatkan langkah kita untuk pergi ke Petronas. Okey, tak apa. Jadi Encik Syazwan, terima kasih banyak untuk perkongsian sebentar tadi. Banyak sangat ilmu yang kami dapat yang kami boleh terapkan.
Aiza, TMC yang comel kita tu ada soalan bertubi-tubi tentang gaji tu. Untuk semangat katanya, untuk semangat. Mungkin Cik Syazwan, sebab mereka nak semangat nak kerja di offshore ni.
Dia kalau okey, untuk salary untuk biasalah kita semua yang lebat-lebat kan. yang tikai-tikai kita kan. So kalau refer to yang professional punya level, which is freelancer lah, geotechnical engineer, freelancer geotechnical engineer, surveyor, freelancer punya surveyor. Maksudnya dia tak ada tie to a specific company, ataupun mungkin in short term tu ada. Contoh short term tu satu projek tu satu kontrak tu mungkin ada. They can gain the salary ataupun income tu around 2,000 to 3,000 a day. Itu on the higher side lah, a day. Yes. For freelancer. Bukan saya biasa je. Tapi kalau freelancer, which is a professional level tu, it can reach to that 2,000 to 3,000 a day. Kawan-kawan saya ramai yang dah touch that level.
A day.
Yeah.
Okey, semua semangat 3,000 sehari tu. Tapi gaji yang besar datang juga dengan risiko dan tanggungjawab yang besar. Betul Encik?
Betul.
Okay,
Tapi itu
jadi
market international lah kan. Macam kebanyakannya my friend they explore to Middle East, to European country, contoh European country kan, dealing with North Sea punya condition. So North Sea is macam monsoon dekat sini tapi mungkin 5 kali ganda ataupun 10 kali ganda hebat dia punya challenges dekat North Sea tu compare dengan Southeast China punya sea kan. So macam all the way tu adalah monsoon time dekat North Sea tu. So very very tough and challenging dengan weather, that kind of challenge lah. So we need to adapt untuk reach that level.
okay. Okay, jadi terima kasih Encik Syazwan. Terima kasih banyak. Okay, semua berikan tepukan untuk Encik Syazwan yang tak henti-henti daripada tadi. Okay. So, Encik, kita ambil gambar dulu boleh?
Boleh.
Okay. Fotografer, Achan?
Saya sini. Saya tolong.
Okay.
Okay. Semua tolong buka mic, buka kamera. Okay, 1, 2, 3. Lagi satu
Lagi satu. Freestyle ke apa?
Freestyle.
Ini okey, freestyle.
1, 2, 3. Okay.
Alright, terima kasih lagi sekali Encik. Semoga kita berjumpa lagi lepas ini.
InsyaAllah, terima kasih kerana jemputan. All safe, please stay safe, take care. Semua dekat rumah kan?
Semua kat rumah Encik. Semua kat rumah.
Seronok belajar kat rumah kan, Dok?
Tak
Boleh lah.
Tak seronok.
Seronok sangat.
Terciduk juga.
Sebabnya tengok muka-muka pelajar ni semua dah muyuk dah. Actually dia need environment yang sedia kala kan. Kita dapat pergi camp yang betul-betul dalam hutan, berhujan, berpanas.
Saya pun actually work from home dah about 1.5 year, Dok. Dah work from home setahun setengah dah Petronas. Since March last year sampailah today. Still work from home Petronas staff.
Encik memang staff isn't it?
For office base lah. Kalau yang operation yang kena ada dekat plant offshore tu masih lagi continue lah.
Kita harap benda ni cepat berakhir lah.
Yes.
Kan? Mr. Syazwan, on behalf of UTHM, saya nak mengucapkan ribuan terima kasih because it's not the first time but we've invited you as a third, isn't it? Kalau ikutkan kita program, this is program yang ketiga. Terima kasih banyak-banyak tidak menolak dan ada pertambahan info dalam slide Cik Syazwan tu.
Ada sikit-sikit je lah, tak banyak.
So, kalau boleh share semula sebabnya mereka ni para pelajar yang ada di dalam platform ni, bukan platform ni maksudnya dalam camp ni akan diberi quiz nanti. Quiz so mereka perlu menjawab quiz jadi mereka dah nervous dah ni. Kenapa doktor bagi slide tak sama dengan Cik Syazwan punya?
Betul.
Dia still not believe me. Walaupun saya kata soalan yang saya bagi tu berdasarkan slide yang saya ada, but they need your slide.
Boleh. Nanti saya share kat Dok.
Okay, nanti Cik Syazwan share, saya pun akan distribute to all of my student lah. Okay?
Baik.
Okay, Mr. Syazwan. Terima kasih banyak-banyak.
Terima kasih.
Thank you all. Baik.
Okay. Bye-bye Mr. Syazwan. Okay, semua happy. Bye-bye. Okay, the rest please stay. Yang lain tolong tunggu sebentar. Okay. Okay, baik. Anda akan berehat. Okay, sebelum tu terima kasih saudari MC. Wow, ayat. Soalan gila-gila
Itulah tu. Saya ikut je.
Okay, soalan gila-gila dia dah keluar. Okay, baik. It is good because this is not a very formal punya platform. Memang kita just nak enjoy dan kita nak ilmu itu sampai kepada kita. Okey, baik. Kita akan berhenti berehat. Okey, berhenti berehat. Jam 2 semua terus ke Uthm. Platform Uthm, terus jawab kuis. Baik. Ketika awak jawab kuis, ketua section akan share dengan awak soalan yang Dr. Mus minta tadi kita buat. Kan? Ada Google Form yang perlu diisi. Okey, yang itu saya akan beri pada ketua dan ketua akan distribute after you finish your quiz. Okey, supaya you tak cram, semua nak jawab dalam serentak. Then semua nak jumpa balik tak pukul 4?
Rehat doktor.
Rehat.
Kepala dah keras.
Tak mau.
Okey, kepala kita semua dah kram. Atas permintaan ramai, saya boleh lihat di dalam platform YouTube juga. So kita rehat. Kita jumpa bersama pensyarah masing-masing pada pukul 9 malam.
Yeay.
Okey,
Tepuk.
Alhamdulillah.
Ada kenapa? Dah bagi berita bergembira pun muka monyok je. Apalah Adila, penat tau saya. Tersenyum sana, tersenyum sini. Okey, terima kasih semua. So boleh berhenti berehat?
Boleh doktor.
Okey doktor.
Boleh doktor.
Alright, okey. Assalamualaikum dan kemesraan. Anda dah tak jumpa lagi bersama-sama selepas ini. Okey, terima kasih semua. Selesaikan tugasan yang diberi bersama pensyarah masing-masing. Okay, love you guys. Take care, please. Take care.
Okey doktor.
Terima kasih doktor.
Terima kasih doktor. Assalamualaikum.
Baik doktor.
Waalaikumsalam. Kedatangan pun hancur pagi ni. Ada yang tak tanda tangan lagi. Okey, bagus.
Terima kasih.
Thank you doktor.
Thank you doktor.
Thank you doktor.
Jumpa lagi.
Sama-sama.
Thank you doktor.
Okay, bye.
Bye.
Bye. Happy semua.
Siapa yang belum sign tu kita tak datang pagi ni tau. Okey, bye. Bye.
Doktor.
Doktor Mus cakap apa tu?
Oh doktor.
Ya, saya.
Nak tanya apa attendance ambil sekali je?
Ya, sekali sahaja.
Alright. Terima kasih.
Itu pun ramai tak sign. Ramai yang tak sign. Bagus.
Yang belum sign
saya conclude dia orang tak datang saja. Bagus. Okey, senang kerja saya. Okey, dia tolak 20 markah, dia tolak 20%. Padan muka.
Guys, sign ya guys, sign.
Lambat pun tolak markah juga.
Okey semua, tolong pergi balik pada attendant ya. Okey. Okey, terima kasih di platform YouTube. Anda memang awesome. Okey. Hari ni saya dapat 2 saja dislike. Okey, 86 like. Tapi kita ada lebih daripada 300 orang pelajar. Maksudnya apa tu di atas pagar?
Okey doktor, terima kasih doktor.
Okey, sama-sama. Okey Dr. Hendy, terima kasih. Okey ni